Hey everyone, welcome to this Apache Kafka Full Course by MindMajix. Imagine you are booking a ride on Rapido. As soon as you confirm your ride, Kafka gets to work behind the scenes, tracking your location real time, notifying the driver, updating your application with arrival time, and even sending that information to Rapido's analytics system. All these events are streamed through Kafka instantly and reliably, allowing the application to work in real time. That's the power of Kafka. And it's not just a Rapido. Companies like Netflix, Swiggy, Zomato, Flipkart, and more rely on Kafka for messaging, user activity tracking, fraud detection, and operational monitoring. In this course, we will guide you step by step through Kafka architecture, producers and consumers, brokers, partitions, ZooKeeper, Kafka Security, and more. According to the job portals, there are thousands of job openings for roles like Kafka developer, big data engineer, and platform engineer. And as per Glassdoor and Ambition Box, Kafka professionals in India earn between 8 to 25 lakh rupees per annum, depending on experience and additional skills in Python, Spark, and cloud platforms. So grab your laptop, follow along with the video, and don't forget to like, share, and subscribe if you find value in this content. And if you want to learn Kafka course with certification, then check out our course where we cover latest industry curriculum, hands-on projects, labs, mock interviews, and more. Check the link in the description below. Now let's dive in and start your Kafka journey right here, right now.
So in topic, we are going to discuss about what are partitions in the topic, what are offsets in the topic, and what is meant by a topic replication factor. And in the broker concept, we are going to discuss what is meant by a broker in Kafka and how does a broker holds a topic. Like whenever we create a topic, how the topic will be handled by the broker, how does the backend file system will be allocated to the topic. A topic, this word topic is a very powerful word in Kafka. So without topic, there is nothing you can do in Kafka. So let's understand about the internals of topic now. So a topic is particular stream of data. It means the data stream will happen between sender application and the receiving application via this topic only in Kafka. So topic is base of everything in Kafka. In Kafka, so everything based on topic only. Like when our application people want to communicate with other application, so the sending application will connect to Kafka, put the message into topic inside Kafka, and the receiving application connects to Kafka and it will connect to that particular topic and it can consume the messages. So that's why this topic is called as particular stream. And this topic is base of everything in Kafka. So without creating a topic, you can't establish a communication among the applications. So we can compare a topic with a table in a database. Like you must listen about a database and you must listen about a table in the database. So what does a table contains in a database? Some data. It could be anything. Same thing, a topic in Kafka, it contains some data. So like a table in a database contains some data. In the same way, topic in Kafka contains some data. Like whatever the data that is being published by producer application, that will be stored in Kafka topic, and whatever the data that is being consumed by the consumer application, that will be consumed from the topic only, because in Kafka, topic has the only ability to store the data, like the messages. So you can have as many topics you want. Like in one Kafka cluster, you can create n number of topics. Absolutely, there is no limit. So your Kafka cluster could be a single node Kafka cluster or it could be a multi-node Kafka cluster. It doesn't matter, but you can create n number of topics. So topic is identified by its name. So every topic is having a unique name in one cluster. So topics are again split into partitions. So for example, when we are creating a topic in any Kafka cluster, we have to specify how many partitions this topic should have. So the topic partition means partition is the place where this topic physically stores the data. So for example, see in my computer, in our computers, we are having this right? When I open my hard disk, I can see C drive, E drive, F drive. So in my computer, my entire hard disk is having 500 GB. So each and every hard disk, I am again partition into C drive, E drive, F drive. So this is a partition of the drive. This is a partition of my drive. This is another partition of my drive. So each and every partition is having some data, right? Same like in Kafka also, in Kafka topic also, there is something called a partition inside the topic, where this partition will be having the particular data. So each partition in topic is ordered, like each and every partition is ordered. So each message in the partition get an incremental ID called offset. For example, if any message got pushed into topic and got pushed inside the partition, then it will be having an ID. That particular message will be having an ID. So that ID is called as offset. So the word offset refers to a message. So when I say one offset, it means one message. When I say 10 offsets, it means 10 messages. When I say 100 offsets, it means 100 messages. So a message is the data that is being published by the producer, and whenever that message is loaded into the topic partition, Kafka will assign, okay, this is the ID for this message. So that ID, we are going to call it as a offset. So one message will be having one offset, means one message is having only one ID. It means one message is having one offset inside the partition. It means initially topic, then inside the topic there would be partitions. Whenever message being published into partition, Kafka will assign a ID to that message, and each and every message will be having one unique offset. So for example, in Kafka cluster, I have a topic. Let's assume this topic can have one partition or two partition or three partition or 10 partition or 100 partitions also. While you are creating a topic, you can decide how many partitions my topic should have. Let's assume in this case, I have decided 3 partitions. So you can go with the one partition also, you can go with the 2 partitions also. But here, let's assume I'm going with the 3 partitions. Now I will tell you in which case you will go with only one partition, in which case you will go with the multiple partitions. I will come to that. So for example, in this case, I have 3 partitions. So whenever, okay, let me open a pen. So whenever an application publishes the message to this topic, now Kafka decides this message should go to this partition or this partition or this partition. Here we have 3 partitions, say partition 0, partition 1 and partition 2, right? So always the partition count will start from 0 in the system language, in the computer language, not from 1. Okay, so partition 0 is first partition, partition 1 is second partition, and partition 2 is third partition, total 3 partitions. So whenever any message being published into Kafka topic, so Kafka will decide that message should go to partition 0 or partition 1 or partition 2. Let's assume initially Kafka internally decided that, okay, that first message should go to partition 0. It means that message will be having an ID. ID is 0. Here 0 is an offset. And whenever messages are keep on writing into partition 0, first message is getting an ID called 0. This ID is an offset. Now second message got an ID called 1. That ID is another offset. Third message, ID number 2. It's an offset. Fourth message, ID number 3. So it's another offset. Like this, we have total 12 IDs, incremental IDs. It will sequentially it will be increased. Starts from 0, and then how many messages are that being published, based on that IDs will be allotted. So one ID you call it as offset. So in partition 0, there are 12 offsets. It means there are 12 messages. Let's assume some messages are published into partition 1. So it is having 8 offsets. It means 8 messages. Let's assume some messages are published into partition 2. So it is having 10 offsets. It means there are 10 messages. Now, come to your question. For example, let's assume there is a Kafka topic. And let's assume its topic name is TP1, and it is having only one partition, say partition 0. Okay. For example, one application has published a message to this TP1, and TP1 is having only one partition. So ultimately, Kafka will put the message into this topic only. So it is going to get the IDs, right? It is going to give the offset numbers like offset 0, offset 1, offset 2, offset 3. Like sequentially, message will be published, right? Now, an application is consuming the messages from this topic, and this topic is having only one partition. So message will come in the orders. So for example, an application, a producer application published message number 1. So that message number 1 is here in offset 0. Now it has published message number 2. So that message is in this offset. Whenever receiving application is consuming the message, first it will consume message number 1. Now it will consume message number 2. Now it will consume message number 3. Like, what is the order the data is being published? In the same order, the data is going to be consumed. That's what the advantage when you have only one partition. If your application is having dependency of message ordering, then you must go with the one partition only. So for example, if your application, your sending application and your receiving application have a dependency of processing in the message order, like for example, if sending application has published in message number 1, then receiving application has to consume message number 1 only.
Right.
Now next message is message number 2, so it has to consume in 100. Second message must be message number 2. It is not going to be message number 3 or message number 4. It has to be message number 2, which is in the second position. Now third message number 3. Now there is an order. When message comes in this particular order, then only your receiving application is going to process that message. If you have such kind of dependency, then you must go with one partition only, because when you have one partition, then there is a guarantee of message ordering. Whatever the order that message is published into Kafka, in the same order, the receiving application is going to consume the message. Right?
Right.
For example, I have, let's assume, more than one partition. Say right now here we have 3 partitions in this case: partition 0, partition 1, and partition 2. So let's assume sending application has published 100 messages from message number 1 to message number 100. So out of 100 messages, let's assume 33 messages are in partition 0, 33 messages are in partition 1, remaining 33 messages are in partition 2. Now a receiving application is consuming all these messages. When it is consuming all these messages, so there are three partitions, right? Now there is no guarantee of the order. So definitely it will consume 100 messages, but there is no guarantee of the order. For example, initially it may get message number 3, then it may consume message number 51, then it may consume message number 1. Like this it will consume. It will not come in an order like message number 1, message number 2, message number 3, message number 4 till message number 100. No, this is sequential order. There is no guarantee because we have multiple partitions. So the thing is, when you have a dependency of message ordering, then always go with create topic with one partition only. But the thing is, the performance would be bit higher when you have more partitions. The performance would be bit lower when you have only one partition, because message should be published in a sequential order. But here, whatever the partition is free, Kafka will automatically send the message to that particular partition, so that the stream would be much faster. The producing and consuming would be much faster. But here, there would be bit slow, but there is a guarantee of the messages. When you have lower messages like 100, 200, 1000 messages, 10,000 messages, that's okay. You don't feel much difference. But when you are sending terabytes of data, then you feel a difference. Now, offset of a partition, you already got a clarity what is meant by an offset. One offset, simply we can say one message. For example, say here, Kafka topic with 3 partitions. Partition 0 is having 12 offsets. It means 12 messages. Partition 1, 8 offsets. It means 8 messages. Partition 2, 10 messages. It means 10 messages. That's all. So offset only has meaning for specific partition. For example, offset number 3 of partition 0, it is having meaning to this partition only. And offset number 3 of partition 1, it is having meaning to this partition only. Offset number 3 of partition 2, it is having meaning to this partition only. So it doesn't mean that offset numbers are equal. It means the data that is being published here and the data that is being published here, they are not same. Definitely they are different messages. So this offset belongs to which partition? Partition 1 only. So it's a different data, it's a different data, it's a different data. So for example, offset 3 of partition 0 does not represent the same data of offset 3 in partition 1. So offset 3 of partition 0 does not be the same data of offset 3 of partition 1. Definitely they are different data, different messages. So data order is guaranteed only within a specific partition. So the order of the data, right, that is having that is guaranteed only in a specific partition. So data is kept only for limited time. For example, whenever data is published into Kafka topic at the back end, those messages will be stored in the partitions. So whenever messages are there in Kafka topic, so there is a specific time span. Till that retention period only, messages will be there in Kafka. After that retention time, messages will be auto deleted. For example, by default, how Kafka behaves is whenever a message is being published into Kafka, by default, till 1 week, data will be preserved into Kafka topic. Till in this 1 week, the receiving application has to consume the data, and it can consume millions of times till this 1 week, because how many times it consumes till the retention period, data will be there. Retention period in Kafka means how much time data will be preserved in your Kafka file system. And the default behavior in Kafka is 1 week. After 1 week, definitely your data will be vanished from Kafka. So you can alter this. You can decrease it, you can increase it based on your business requirement. If I want to put it for 14 days, or if you want to put it 30 days, of course, you can definitely do that. For that, we have to modify the configuration from Kafka side that we'll see in future classes. So once data is put into in a partition, it can't be changed. For example, whenever any message is published into Kafka partition, into Kafka topic partition, that's it. You can't change it. So data is assigned to a partition randomly. For example, whenever a message is being published, so that can go to this partition, or that can go to this partition, or this can go to this partition. So we do not have any control over it, but Kafka internally takes this kind of load balancing. So whether it should go to partition 0, or it should go to partition 1, or it should go to partition 2, it is not in our hand. Now let's talk about a broker inside Kafka. So what is broker? Let's see that. So a broker is a server where Kafka is installed and running. For example, there is a Linux server, and in this Linux server, I have installed my Kafka, and I have started Kafka cluster also. It means it's now a broker. So in Kafka world, broker means it is a server. It's a physical virtual server where your Kafka is running. That's it. So Kafka cluster is composed of multiple brokers. When you take any Kafka cluster, it can have one server, or it can have multiple servers. It means it can have one broker, or it can have multiple brokers. A broker in Kafka cluster is identified by a unique ID. So whenever a broker is running in Kafka cluster, it means that particular broker is identified by a ID. So it is not identified by the server name. For example, when there is a server, definitely that particular server is having a host name, right? So whenever you added that server into Kafka cluster, so we call that server as a broker, and that broker is having a ID. Like in Kafka server.properties file, we are going to configure the broker.id. So we will give a ID. It is any integer, any number. So Kafka cluster identified by your broker by its ID, not by its host name. So when we are installing single node Kafka cluster, there I'm going to explain you how to assign a broker ID to a server. So each broker in Kafka cluster contains certain topic partitions. For example, one Kafka cluster is having, let's assume it is having 5 brokers, because it's a multi-node Kafka cluster. It means it's having 5 brokers, 5 servers. So each and every broker contains certain topic partitions. For example, I have created a topic TP1 with 3 partitions. It means one partition will be another one broker, second partition will be another broker, third partition will be another broker. It will be segregated like that. So which partition of the topic will go to which broker, that is again not in our hand. We do not have any control over it. From Kafka admin perspective, we can just give a command of creating a topic with these many partitions. That's all. We do not have any control. This topic partition should go to which broker. No, we are not the. We can't decide that. Kafka will internally manage that. So after connecting to any broker, you will be connected to the entire Kafka cluster. For example, I have a Kafka cluster with 5 nodes, 5 brokers, broker 1, broker 2, broker 3, broker 4, and broker 5. And an application people wants to put a message into your topic. Let's assume I created a topic with some partitions, say 3 partitions. And if an application, the producer application wants to put a message into the topic, so what it will do is out of 5 brokers in this entire Kafka cluster, it can use one host. It is not mandatory that it has to use all the host of all the broker names. No, not needed. When it can use one broker, that's it. It means that connection will be distributed the load to all the brokers inside the Kafka cluster. Again, Kafka will take that load, so you no need to worry about it. So generally, a broker holds the topic. For example, when we create a topic, physically the topic file system will be created inside the broker only. So what is broker? It is like a Linux server only. In the server, we have a storage, we have a file systems, right? Inside the file system, that particular topic will be created. Now let's see how does a broker hold the topic. It's very simple. See this diagram. For example, I have created a Kafka cluster. Like I have a Kafka multi-node Kafka cluster with 3 brokers. It means 3 servers. So first server is having a broker ID 101, second server broker ID 102, third server broker ID 103. It means 3 brokers are having unique IDs in one Kafka cluster. So this is like Kafka cluster. Okay. Let's assume I have created a topic called topic K. Topic name is topic K, and it is having 3 partitions. And for topic A, partition 0 has gone to broker 101, and for topic A, partition 1 gone to broker 103, and partition 2 gone to broker 102. So one topic, 3 partitions. Each and every partition is equally distributed to all the brokers. So which partition of that particular topic should go to which broker? That we can't control it. So Kafka internally decide, okay, you go to this broker, you go to this broker. So it will be internally managed. Let's assume I created another topic, say topic B, with 2 partitions. So for topic B, partition 0 has gone to broker 102 of the cluster, and partition 1 of topic B has gone to broker 101 inside the cluster. So this is how the partitions, the topic partitions will be managed by the broker. So the data is distributed, and broker 103 does not have any topic B data. For example, if you see broker 103 does not have any partition of topic B, because topic B created with 2 partitions, and 2 partitions are allotted in broker 1 and broker 2. Broker 101 and broker 102. For broker 103, it doesn't have any representation of it is not storing any physical data of topic B, because done, your out of 3 brokers you created only 2 partitions and it's allotted. Now let's talk about something called replication factor of a topic. So in the previous slides we have seen about partitions, right? Now we are going to discuss about the replication factor of a topic. So this replication factor of a topic is also another important property of a topic. So a topic, when you are creating a topic, right, even in the real time, you need to take care of 2 things. Number 1, partitions, that we already discussed some time back. Now we are the second important thing is replication factor. This is another important thing while we are creating a topic. So let's see now what is meant by a replication factor in the topic. A replication factor is a number that indicates number of copies of a particular topic. For example, when you are creating a topic, how many replicas you should have for that particular topic inside your Kafka cluster. For example, while I am creating a topic and I have given replication factor 2 of the topic, it means the topic will be having 2 replicas. 1 replica in one broker, 1 replica in another broker. So that if one broker goes down, another broker will be having to serve your data. So we'll see that with the diagrams. So for example, if a topic is created with the replication factor 3, it means topic is created only once, but it will be having 2 more additional copies, because total replication factor is 3. 1 copy you create with the command. So what Kafka will do is, as it is having replication factor 3, fine, make another 2 replicas, so that entire replication factor will match to number 3. So this is for fault tolerance purpose. So we have already seen Kafka has the greatest advantage called fault tolerance. It means although one instance is down, another instance of the cluster can serve your application. So see, fault tolerance is a property that enables a system to continue operating properly in the event of a failure of some of its components. Topic should have replication factor always greater than 1. So in Kafka, what is the recommended standard is when you are creating a topic, especially in the production, always make sure you should have replication factor greater than 1. Could be 2 or 3. 3 is really a good number. Even never go with the 2. When you have multi-node Kafka cluster with 3 brokers, then go with the replication factor 3. So that although 2 systems are down, third system will be available to serve your application. So this way, if a broker is down, another broker can serve the data. For example, see this diagram. So I have a Kafka cluster with 3 brokers. Broker ID 101, broker ID 102, broker ID 103. Right? For example, I have created a topic called topic A, and it is having 2 partitions. Say partition 0 and partition 1, because I have given partition count is 2. And also I have given replication factor 2. It means each and every partition of the topic will be having 2 replication factor, will be having 2 copies. For example, if you see this diagram, broker 101 is holding partition 0 of topic A, and also we have decided that this topic should have 2 partitions, right? So partition 0 is there. Now partition 1 is in 102. Fine. But we have given replication factor 2. It means each and every partition should have another copy. So partition 0 of topic A, 1 is already we created in 101, and another will automatically Kafka creates in another broker, which is in 102. In this case, it is created in 102. And also for partition 1 also, 1 copy is created with the help of command, and remaining with the help of replication factor 2. Okay, it should have another copy. So what Kafka will do is, it will create another copy of partition 1, either in broker 103 or in broker 101. But in this case, it is created in broker 103. So now see topic A, partition 1 is in 102, another copy of partition 1 is in 103. Also for topic A, partition 0, 1 copy is in 101, another copy is in 102. So simply we can say replication factor means having more than 1 replica, more than 1 copy of same partition of the topic. That is called replication factor. See this diagram. Let's assume broker 102 is down. Broker 102 is down, then there would be no issue for the application, because for topic A, partition 0 is available, partition 1 is available. All 2 partitions are available. So definitely it won't impact the receiving application. If in the case of broker, 1 broker goes down, but if this is also goes down, or if this is also goes down, then yes, it's a problematic. Generally, the thing is when you have 3 brokers, right, in Kafka cluster, always go with the replication factor 3. This is highly recommended, especially in the production, so that in all the 3 brokers you will be having all the replicas. Then although 2 brokers are down, still 1 broker, all the copies are presented. That's the criteria you should go. So, and one more thing, it doesn't mean that if your Kafka cluster is having 100 brokers, then I can create a topic replication factor 100. Yes, technically it is possible, because you have 100 available brokers now. It means you can create 100 replication factor for 1 topic. But this is not at all recommended. 3 is really good number. When you are creating a replication factor 100, there would be network lag, there would be performance issues, because each and every broker must talk to each and every broker, because 100 replication factor, right? Whatever the message that being published into 1 copy, that should be replicated to all the 99 copies, which is a network lag, which is again a performance issue. So don't do that. Although you have hundreds of brokers, although you have 1,000 brokers in 1 Kafka cluster, always go with the replication factor 3 only. It's because 3 is really good number, even in the production systems also.
Okay.
Like, because especially in the production Kafka cluster, if all the 3 brokers are goes down, you won't sit idle, right? Definitely you do some research, you will see why broker, and you will try to immediately make the brokers up, because it's a production bus. How can you sit idle if the production broker goes down? You will get a P1 or P2 ticket. Now there is some concept of leader for a partition in a topic. Now we know that we have a clarity what is meant by a replication factor for a partition in Kafka topic. Now we need to understand what is meant by a leader of partition. For example, my Kafka cluster is having 3 brokers: broker ID 101, broker ID 102, and broker ID 103. It means that Let's assume topic A has been created with two partitions and two replication factors. So partition 0 is one copy of partition 0 is 101, another copy of partition 0 is in 102, and we have created another partition, right? Total two partitions. So one partition, two replication factor, done. Now second partition, two replication factor, done. Now what happens is, at any time Kafka decide, okay, when there are two copies, more than one copy of a partition, one copy of the partition will become a leader and another copy will become in-sync replica. So in-sync replica means that will be keep on following that particular partition leader. So for example, the one which I made the star, right? Let's assume that has been elected as a leader. So Kafka decides which copy of partition should be a leader, which copy of the partition should be an in-sync replica. That will be again decided by Kafka. We have nothing to do on it. Now see, at any time, one broker can be the leader of a given partition. For example, for partition 0, the copy which is in 101, let's assume broker 101 for partition 0 and broker 102 for partition 0. So partition 0 is now in two brokers. I mean, one copy is in 101, one copy is in 102. So now 101, here in this case, 101 has been decided for partition 0. Okay, you become the leader. Broker 101 is the leader for partition 0, and for the partition 0, broker 102 is the in-sync replica. For partition 1, broker 102 has been elected as a leader, and for partition 1, broker 103 has been elected as a follower. It means it's a in-sync replica. Now, whenever a message is being published into Kafka topic, that message, first of all, it will be published into leader partition only. It means in broker ID 101 only. So the remaining in-sync replica thing is right. That will just follow this leader. It means whatever the data that is being updated in partition 0, so he will get the data. This partition 0 asks, hey, dear leader, please give me your data. I need to in-sync with you. So that leader will copy the data into this partition 0. So this will be, this follower partition will be in sync with your leader. So that's why this person is called as in-sync replica. So at any time, one partition will be the leader and remaining all are in-sync replicas. For example, I have created replication factor 3, means another partition 0 will be created in broker 103. So he will become another ISR, in-sync replica. It means for partition 0, there is one leader and two followers, two in-sync replicas. So this is how it should be. So only that leader can receive and serve the data from the partition. So for example, when a application puts the data, initially leader will be updated and that leader will give the data to the followers, to this one and to this one. So the other broker will just synchronize the data. I mean the follower broker will just synchronize the data. That's it. This is completely internal. So Kafka will take care of these things. So therefore, each partition has one leader and multiple ISR, I mean multiple in-sync replica. And here one more question. For example, if a leader broke down, now what happens? Right? For example, for partition 0, broker 101 has been elected as a leader. Let's assume my broker 101. What is this broker 101? It's a server only. It's a Linux server only. If the server is down due to any issue, then what happens is another in-sync replica. Right now for partition 0, we have two in-sync replicas, right? So one in-sync replica will get the leader privileges. He will become a leader. Kafka decides, hey, this broker is down. Now you become leader. So that broker 102 will become leader for partition 0. Now he will be the leader. He will be in-sync replica. So that's how Kafka gains. So in this session, you will be able to understand about what is meant by a producer, a consumer, and then ZooKeeper. So also in producer, what is a producer? And then producer with message key. In consumer, consumer groups, and then consumer delivery semantics. And then in the ZooKeeper, what is a ZooKeeper and its role in Kafka? So these are things we are going to typically understand about. So let's talk about producer. So I believe with the help of yesterday's session, you already got some familiarity what is meant by producer. Simply, producer publishes the data to Kafka. So it could be any application, as simple as that. So producers write data to topics, and producer automatically know to which broker and partitions they write to. For example, I have a Kafka cluster, and one second. So I have a Kafka cluster. So it could be a single node Kafka cluster, or it could be a multi-node Kafka cluster. So I have a Kafka cluster, and let's assume it is having, if it is a multi-node Kafka cluster, there would be, let's assume there are 5 brokers. Say broker 1, broker 2, broker 3, broker 4, and broker 5. And let's assume I have created a topic inside this Kafka cluster. So let's assume I have created this topic with 3 partitions. So as there are 5 available brokers in this cluster, creating a topic with 3 replication factor, that is absolutely possible. So one copy of this topic will be here and here and here. So remaining 2 brokers will not be having any entry related to that particular topic, because out of 5 brokers, although you have 5 brokers, you created the topic with a 3 replication factor. So 3 copies are now created. Now, whenever a producer from the client, he tries to publish to the message to that particular topic, the thing is, in his connection parameters, he has to give any minimum any one of the broker. He no need to give all the brokers list. So this is one server, this is another server, this is another server, and another server. So he will give one broker name. So that's it. So if he is connecting to one broker, it means at the back end, he will be connecting to all the 5 brokers in the cluster, right? That's what we have seen yesterday. Okay. So for example, in my Kafka cluster, I have 3 brokers. Say broker 1, and running at a port number called 9092. 9090 is a Kafka default port number. Okay. And they have another broker called broker 2 9092. They have another broker 3 9092. Broker in the sense it's a server only, but in Kafka world we call the server as a broker. So another broker 4 9092, and another broker 9092, which is broker number 5. So total there are how many brokers? Total there are 5 brokers. Now the application people, we have given to the application people, hey, these are all the 5 brokers running at 9090 in my Kafka cluster. Now what application people will do is, so they will write down a producer program, say Kafka console producer, some producer program they will run, and there is something called a bootstrap server. Bootstrap server means our broker list only. So the thing is, they can give all the 5 brokers list like this. So there would be no spaces when they are giving the things. And then they will give something called hyphen topic, and then the topic name, say TP1. So they can give like this, all the 5 brokers they can include, or they can give any 2 brokers. Let me do one thing. So they can give any 2 brokers like this. So this is also the right option. Or if so, if they have given something like, let's assume only 2 brokers they have given, this is also same result. Or they have given only 1 broker, this is also same. Everything will give the same result. They have to connect any minimum one of the broker of the entire Kafka cluster. So ultimately everything will give you the same result. So this is how they will include the brokers list. The thing is, once they connect to 1 broker, right, that's fine. So they will be connecting to all the remaining 4 brokers at the back end, and data will be published. But the thing is, in the case of broker failure, producer will automatically record. For example, let's assume they have given all the brokers. And what happens is, initially a producer will verify if the connection is fine in this broker. If the connection is fine, then the producer will not take care of all the remaining 4 brokers. It will directly connect to here, and it will search for this topic and will produce the messages. And let's assume, let's say in this cluster, this broker is down due to any issue. Now the producer will automatically know, okay, now I need to connect to this broker. Now it will publish the messages by connecting to this broker. Now let's assume these 2 brokers are down. That's fine. Remaining, I have another connection name. So I will try to connect here. If this is fine, I will successfully publish the messages. If this is also down, then I will connect to broker 4. If this is also down, then I will connect to broker 5. If all 5 brokers are down, then this producer will be unhappy. This producer won't produce any messages. So that's how it is. If any broker goes down out of the brokers list you have given, so a producer automatically know, okay, I have to connect this, or I have to connect this, I have to connect to this. It will, this load balancing will be automatically handled by Kafka itself. You don't need to worry about it. Only one thing is you have to give the available brokers list. That's it. But in the case of you are giving only one broker list, and this must be available. If this one broker is down out of 5, that's all. This producer will be unhappy and it won't produce any message to target, because you have given me only one broker list and I'm connecting to this, but this broker is not available, so I can't produce the messages. So that's how it is. Okay, see, so the load is balanced to many brokers. So thanks to number of partitions. So as we have number of partitions, Kafka will decide, okay, this partition is free, message should go to here, or this partition is now free, so message should go to here. So that will be internally decided by Kafka. Okay. So producer can choose to receive the acknowledgement of data rights. For example, if any producer produces the messages, so what does a producer, how does a producer gets confirmation? Yes, my data has been successfully published. The thing is, producer can choose to receive the acknowledgement of data rights from Kafka brokers. For example, see, a producer is producing the messages like this, and come on. So there is something called x equal to 0. It means whenever a producer producing the messages, like whenever a producer producing the message like this, at the end they can choose something x equal to 0. There is, it is a producer property. So it's like okay. Anyway, so this producer property we will discuss in the command line interface. Okay. So they can choose x equal to 0. I mean, the producer can choose x equal to 0, or x equal to 1, or x equal to r. These 3 acknowledgement the producer can choose while producing the data. Let's assume producer chooses x equal to 0. It means that producer won't wait for the acknowledgement. For example, producer is producing the messages and it has chosen, hey, x equal to 0. It means, hey, Kafka, don't give me any acknowledgement. I totally trust you, so you just blindly proceed. So that's what the meaning of x equal to 0. But the problem is there is a possible data loss. For example, a producer is producing the message to broker 101 with x equal to 0, right? And the message is in the air, and the message is when it is in the air, let's assume due to some network issue, message got vanished. So the producer never wait for broker acknowledgement, and it will blindly proceed for the next message. The reason is x equal to 0. It means you are not waiting for acknowledgement, and although the message is vanished, you are not taking care of that. So if data is lost, that's it. Your data will be lost. The producer does not know if my data has been successfully published or it is not done. So there would be no guarantee of that. This is what x equal to 0. And let's assume x equal to 1. It means that producer will wait for leader acknowledgement. For example, okay, I will show you something here. Topic A. Let's assume topic A is having only one partition. So topic A, and it is having only one partition, but it's having 3 replication factor. As we have 3 available brokers in this Kafka cluster, 3 replication factor is available. So one partition means, so this will become also partition 0. This will become also partition 0. So topic A, one partition, 3 replication factor. So partition 0, one replication factor is in broker 101, another copy is in broker 102, another copy of partition 0 is in 103. Let's assume for partition 0, broker 101 has been elected as a leader, and broker 102 for partition 0 is a follower, which means in sync replica, and broker 103 for partition 0 is another follower, another in sync replica. Let's assume this is the case. It means that whenever a producer chooses x equal to 1, it means producer will wait for leader acknowledgement. It means whenever message is published, so what producer will do is, producer will never go to next message to process. What it will do is, hey, leader broker, please give me acknowledgement that data has been successfully written into your offsets. Now broker will give you, at the back end, broker will give you some acknowledgement. Yes, I have successfully received your acknowledgement. So then immediately producer will go for the next message. It will try to produce the next message as soon as it has received the acknowledgement from the broker. And producer will never wait for the follower brokers, because if X equal to 1 means it will wait for the leader acknowledgement only. So it will never wait. Is my data got replicated to all the followers? That thing will not be verified by the producer, because X equal to 1 means only it will wait for the leader broker acknowledgement. That's it. But here there could be limited data loss. For example, your message will be definitely there in leader broker of partition 0, that's for sure. But after message being published, as this partition 0 is having another 2 copies in another brokers. So the sync replicas, they have to replicate the data to this broker, and they have to replicate the data to this broker also. But this producer will never wait. Is my data get replicated to all the brokers or not? No, it will not verify for that. So whenever data is getting replicated, if there is a loss here, then it's loss. So it's a limited data loss. In broker, your data is there, but it is getting replicated to all the existing replicas. There is no guarantee of that, because you are not waiting for the followers acknowledgement. That is what X equal to 1. And this X equal to 1 is the default behavior of Kafka while producing the messages. So clear with X equal to 1, a producer will use all the brokers list, and from which broker it has to read, it will automatically know, right? In the same way, whenever a consumer consuming the data, they will use some command called like this: Kafka console consumer, and the bootstrap server is going to be all the Kafka brokers list and then the topic name. Now consumer know, okay, should I connect to broker 1, should I connect to broker 2, or should I connect to here, should I connect to this, should I connect to broker 5? So the consumer automatically knows which is available broker, and from there it will consume the data. So whatever the concept that is applying on producer side, the same concept will be applied on the consumer side as well. So in the case of broker failures, consumer know how to recover. For example, we have given all this list, right? Out of this list, let's assume when the consumer is consuming, let's assume this broker 1 is down. So now what consumer will do is, okay, this broker is down. Fine, let's try to connect to this broker. If this is available, it will try to connect to this topic and it will try to consume the data. And let's assume if this broker 2 is also down, now consumer automatically goes for broker 3. Is this broker available? Yes, this broker is running. Okay, now let's connect to TP1 and then consume the data. If this broker is also down, that's fine. I have another two in the list, right? Let's connect to broker 4 and get the data. If broker 4 is also down, then fine, let's connect to broker 5 and try to consume the data. If all the brokers inside our Kafka cluster is down, then the consumer will be definitely unhappy and will throw you an error called, hey, broker is not available, I can't consume the data. So you will get such kind of error. Okay. In this notepad, see, a consumer is consuming the data by giving all the consumer groups, and also in the real time, whenever a consumer is consuming, they will use some group called, say, G1, where G1 is the name of the group. So here G1 is a consumer group in this Kafka. With the help of this group, a consumer is consuming from a server. Also, there is another consumer. Let's assume this is application server 1, where producer program is running. Now there is another application server, say application server 2. From the same application server, another consumer is running with the help of same group G1. It means now in G1 group there are 2 consumers. So this is in one IP address. Say, okay. So this is host name application server 1, and this is another host name application server 2. So 2 consumers are using same consumer group. It means now in G1 consumer there are 2 consumers. Let's assume there is another application server. So application server 3, where consumer application is running, and it is also executing the same command in its program, and it is also using same consumer group. It means now in one consumer group there are how many consumers? 3 consumers are running. One consumer from application server 1, another consumer from application server 2, another consumer from application server 3. Okay. So like this, they can use a group ID. So group ID means here G1 is a group ID. It is called as a group ID or group name. Both refers to the same thing. So the thing is, what is the advantage when they use the group ID? What is the advantage? Why they have to use this group option? Why can't they connect as an orphan connection without using any group ID? Why can't they connect? What is the extra advantage you are going to connect as a group ID? Simply, you can say whenever a consumer is using a consumer group ID, that particular consumer will be having an identity. If in Kafka, that particular consumer is having an identity, it means Kafka knows, okay, this consumer group has committed how many messages from that particular topic, how many messages it has consumed. Some kind of identity will be there. For example, see, when we born, right, what's our identity? Our parents only. Wherever we go, we inform, hey, these people are my parents, right? So that we will be having an identity. But if you see, there are orphans, they don't have any identity. So they, when they do something, they will be faced. They have to face so many complications, right? Because they don't have any identity because they're orphans, right? Same way, whenever a consumer is consuming, in real time, they will give a group identity for that consumer, so that Kafka will identify, okay, this group ID has did this work in my Kafka cluster. So Kafka will get such kind of identity internally. That's the purpose of giving a group ID. Whenever, let's assume from all these three application servers, all these three consumers are connecting at the same time by using same group identity. And they are connecting to the same Kafka cluster. They are connecting to this topic one. And let's assume this topic one is having only one partition. Now this one partition will be assigned to either this consumer or this consumer or this consumer, because they're connecting, they're using same group ID. In Kafka, the blind rule is one Kafka consumer of the same group can connect to one partition at the same time. So all the consumers from the same consumer cannot connect to the same partition at the same time. So that the advantage will be duplication will be prevented. Now I will show you. Okay, so it is not in our hand, like when you create this topic should have the copy in this broker. No, it is not in our hand. Technically, we can't decide it. Internally, Kafka will decide, okay, this topic should go to this broker, this topic should go to this broker. So ultimately, each and every broker responsibility is to hold topic data. That's it. Okay, so for example, okay, let's assume this is TP1 and let's assume this is TP2. So TP1 is in broker 1. This is broker 1, broker 2, broker 3, broker 4, and broker 5. Let's assume TP3 is created with the 3 replication factor. It means that when it is created with the 3 replication factor, let's assume this for this topic, the partition will be, for example, 1 partition and 3 replication factor, right? It means that 1 partition will be having 3 copies. So let's assume 1 copy is in broker 1, another copy in broker 2, another copy in broker 3. It could be like this, or 1 copy in broker 5, 1 copy in broker 4, 1 copy in broker 2. So it could be in any broker inside the cluster, but there will be 3 copies of the partition. Okay, so if you connect to any of the broker inside this cluster, so total there are 5 brokers inside the cluster. So you can connect to any one broker. It means at the back end, you will be connecting to all the brokers. Although you have 100 brokers in the cluster, you just connect to one broker. The remaining 99 brokers will be automatically connected. So that is that load balancing will be automatically handled by Kafka. So that is the reason when producer automatically know if it is connected to one broker, it will automatically know to which broker and partitions it should connect to publish the data successfully. So in the case of broker failures, producer will automatically recover. For example, we have given all the 5 brokers list, and out of 5, this producer is giving 3 brokers list in their code while publishing the messages, right? So say broker 1, broker 2, broker 3 they have given, and initially what happens, they will give, okay, see here. So Kafka cluster with 3 brokers. For example, I have a Kafka cluster with 3 brokers, say broker 101, broker 102, broker 103, and there is a topic called a topic K, so which is having 3 partitions. So partition 0, partition 1, and partition 2. So topic K partition 0 is in 101 broker, topic K partition 1 is in 102 broker, topic K partition 2 is in 103 broker. For example, there is a producer and it is trying to write the data in topic K. So in the producer side, they will just give the broker name and then the topic name. So whether the message should go to partition 0 or partition 1 or partition 2, that will be decided by Kafka. You don't have, I mean, producer can't decide my message should go to partition 0, my message should go to partition 1. No, producer can't decide it. Okay, so let's assume if it goes to partition 0, it means offsets will be created. It means message will be publishing. Now, if it is going to partition 1, so message will be publishing. So all these are the offsets, the boxes, the rectangle boxes you see, all these are the offsets. And if it is going to partition 2, then the message will go to here. So this is how. So here, Kafka will do an internal load balancing. Okay, boss, you go to this partition, you go to this partition, this message go to this partition. So which partition this message go to, that will be decided by Kafka itself internally. We do not have any control over it. Now let's take Ax equal to all. Ax equal to all means producer will wait for a leader plus replica's acknowledgement. It means whenever producer produces the message to topic A, so first of all, the data will be there in partition 0 of broker 101, and broker 101 will give a acknowledgement to producer that, hey producer, yes, I have your data now. Now producer will be happy, okay, my data is in leader. Now also producer will wait for broker 2 acknowledgement also. It means whenever data got copied from leader broker to follower broker, this broker will send acknowledgement to producer, hey producer, yes, your data is copied to me. Now producer will be more happy, okay, my data is getting copied to this person also. Now the data will be also getting copied to broker 103, because replication factor 3, it means that message should have 3 copies. So now the final copy, whenever the final broker says, hey producer, yes, your data, I have your data, and this is my acknowledgement. Whenever producer reaches acknowledgement from all the brokers in the cluster, it means producer will go for the next message to produce the next message. Till then, it will never produce the next messages, because Ax equal to all, and all the brokers of the Kafka cluster has given the acknowledgement to broker. Yes, now the broker is happy. I mean, now the producer is happy, and it will produce for the next message. But in this case, there would be definitely no data loss, because data will be published into leader broker first, and all the brokers will give the acknowledgement, yes, I have the copy. It means there is no data loss. You can confidently go for the to process next message. So that's what Ax equal to all. So we are going to see all these scenarios while in the concept of CLI. But this acknowledgement, this is completely back-end process. We don't process, we don't feel that, yes, it is sending acknowledgement, we don't feel that, but at the back end, this will happen. When this happens, then only the next message will be processed, otherwise next message won't be processed. Okay, here one more thing. So generally the default behavior of Kafka is going to be, in Kafka, the producer behavior is going to be Ax equal to 1. It means if we have not specified any acknowledgement, then Kafka automatically gives the producer, gives the confirmation from the leader broker. This is the default behavior. Now let's go with the producer with the message key. So producer can choose to send a key with the message. Alright. So the thing is, while producing the message in Kafka, producer can choose to send a message with the keys. Now, if key is equal to null, it means if a producer is producing the messages without giving any key, then the message is sent in round robin fashion to all the brokers. For example, I have a Kafka cluster with 3 brokers, broker ID 101, ID 102, ID 103, and I have created a topic with 1 partition, and this topic is having 3 replication factor. It means one copy of partition is in broker 101, another copy of the partition in broker 102, another copy is broker 103. That is what the replication factor 3. Right? So whenever a message is producing by the producer without a key, then the message will be distributed in a round robin fashion. So it will go to broker 101, the next message can go to broker 102, the next message go to broker 103. Now the fourth message will go. So if a key is sent, for example, if a producer is sending a message with the key, then all the messages of that particular key will send to the same partition. It will never go to the another partition. This is guaranteed in Kafka. For example, okay, series diagram. Let's assume I have a broker. I have a Kafka cluster with two brokers, broker 101 and broker 102. And I have something called topic with two partitions, say partition 0 and partition 1. Let's assume Kafka cluster is having two brokers and a topic is created with the two partitions, so with one replication factor only. Okay, so partition 0, one copy, and partition 1, one copy. So, and two partitions. Now, a producer is sending the data. If it is sending the data without a key, for example, message number 1, this is my first message. When this is being sent, it means that the message, let's assume the message has gone to partition 0 for the first time. Now, whenever a producer is sending the data without a key, say the second message is, say, message number 2. Now, this message number 2 will go to partition 1. Now, it is again sending message number 3 without a key, then the message will go to partition 0. Now, message number 4 here, message number 5, message number 6, message number 7, message number 8, like this in the round. So, when a message is being sent without a key, simply it will be distributed in a round go to any partition. This is not in our control. But if a key is sent, for example, message 1 is being published and it is having a key called K1. K1 is equal to message. So where K1 is a key and message is a value for that key. So initially, the message that being published with the K1 key, let's assume it has gone to partition 0. Okay. And another message being published with K2 is equal to message number 2, where K2 is another new key and message 2 is the value for K2. Let's assume this K2 has been published to partition 1. Now let's assume message 3 be published with a key called K1. K1 is equal to message 3. Right? Now what happens is, previously there is already one message called message 1 that has been published with the K1. So, and this message has gone to partition 0, right? So, whatever the message being published with the same key, with the key 1, that will go to the same partition only. It will never go to, it will never distribute it in a round robin fashion. No, this is not going to work when you are publishing with a key. The simple logic is, initially with that particular key, that message gone to which partition? To the same partition, all the messages respective to that particular key will go to the same partition. And let's assume if there is a message number 4, and for message number 2, I'm giving something called K2, message number 4. And already a message with the same key has gone to partition 1, right? Now, when you are publishing any new message with the same key, that will go to the same partition. It will never go to, it will never distribute in a round robin fashion. So that is the difference when you publish a message without a key and when you are publishing with, when you are publishing messages with the key. Alright. So if you see the example here, let's assume we have a transport company and let's assume we have 4 trucks. Like, so what all these 4 trucks will do is it will do transportation. Okay, so let's assume for all the 4 trucks we have given, truck ID 123, truck ID 234, truck ID 345, truck ID 456, total 4 trucks. And let's assume you are sitting in your office and you want to track the status of your trucks. So for example, if you want to see, hey, I want to know where is my truck location. So my truck ID 234 location is in which part. So whenever this truck ID, for example, today it is in Hyderabad and tomorrow, let's assume it is in Mumbai, day after tomorrow it is in Kolkata. So it is rotating, right? It's a transportation, right? So the thing is, whenever you enter a truck, whenever you are entering a message with this truck ID 234, let's assume that the message is going to partition 0. Next time, when you enter any message with this key, truck ID 234 is the key, that will go to the same partition. It will never go to another partition. For example, if you want to know the location of truck ID 456 and truck ID 456 is your message key, now the message, yes, today it is in Hyderabad, tomorrow it is in Mumbai, next day it will be in Kolkata. So something like that, then all the data that is publishing with this key, that will go to the same partition, which is partition 1 in this case. It will never go to a partition in Kafka. Now, that's all with the procedure. Now, let's talk about something called consumer. Okay. So, consumer means consumer read the data from a topic and consumer know which broker to read from. So like when we are producing the data, so data is read in the order from each partition. For example, see this diagram. So for example, I have a 3-node Kafka cluster where broker ID is 101, broker ID 102, and broker ID 103. So there is a topic with 3 partitions and okay. So 3 partitions and 1 replication factor, which means each and every partition will be having only 1 copy. So partition 0 is in broker ID 101, partition 1 of topic A is in 102, partition 2 of topic A is in 103. And let's assume each and every partition is having some messages. Like in this case, these are the offsets, it means messages. Total 11 messages, it means 11 offsets. In partition 1, total 7 offsets, it means total 7 messages. In partition 2, total 10 offsets, it means total 10 messages. Now let's assume a consumer is reading the data from topic A of partition 0. So it will read in the order. Initially it will read offset number 0. Now it will read the message from offset number 1. Now it will read the message from offset number 2, then offset number 3, then offset number 4. Like this, it will read the message in a sequential order. It will never read the message in a zigzag order. First read the message from offset number 5, then read the message from offset number 2, then read the message from offset number 11, then offset number 0. No, it will never follow the zigzag order. It will follow order from each partition. So that's how data will be consumed. Now in consumer, there is something called consumer groups. So this consumer groups concept is very, very important. So follow me clearly here. Okay. So consumers can join a group by using the same group ID. Like for example, whenever a consumer is consuming the data, they can use a consumer group ID. So see, Kafka assigns the partitions of a topic to the consumer in a group so that each partition is consumed exactly one consumer in the group. Kafka assigns the partitions of a topic to the consumer in a group so that each partition of the topic is consumed exactly one consumer in the group, which means the diagram will give you a clarity. For example, I have a Kafka cluster. In the Kafka cluster, I have created a topic with 3 partitions. So topic A, see, topic A, topic A, topic A, it is having 3 partitions. Let's assume I have created this topic with 3 partitions, say partition 0, partition 1, and partition 2. Okay. Now, I have a consumer group called consumer group 1. So this consumer group 1 is the group name, consumer group name. And I have another consumer group, say consumer group 2. I have another consumer group, say consumer group 3. So total 3 consumer groups. Now, consumer group 1 is having 2 consumers, say consumer 1 and consumer 2. So this consumer is running from one application server. This consumer is running from another application server. But they are using same group name. Now in consumer group 2, there are 3 consumers, say consumer group 1, consumer group 2, consumer group 3. All these 3 consumers are running from a different application servers. Now in consumer group 3, there is only one consumer. It means only one consumer that is using consumer group ID 3. Perfect. Now the meaning of the point number 2 here is very simple. For example, consumer 1 from consumer group ID 1, the one you see in blue color, right? It's a consumer group 1. So let's assume the consumer 1, by using consumer group ID 1, it has connected to topic A and it is consuming the message from partition 0 of the topic. It means that the consumer 2 from the same consumer group ID, it cannot connect to the partition, to the same partition at the same time. It has to wait till it has processed all the messages. That's what the point number 2 is. So now, but this consumer 2, right? This consumer 2 can consume the messages either from partition 1 or partition 2, because from consumer group 1, partition 1, partition 2, they have not consumed the message set. So it can consume from partition 1 and it can consume from partition 2 also. But consumer 1 from consumer group ID, now it cannot consume the message from partition 1 and partition 2 because already one consumer is consumed with the help of same consumer group ID. Now let's come to consumer group ID 2. For example, there are another three consumers which are in orange color. and it is using called a group ID called consumer group 2. Let's assume consumer 1 from consumer group 2, it is consuming the message from partition 0. It means the consumer 2 and consumer 3 from same consumer group, they cannot consume from partition 0, correct? They can consume the message from partition 1 and consumer 3 can connect from partition 2. So now see, consumer 1 is connecting from partition 0. I mean, consumer 1 is consuming from partition 0. It means consumer 2 and consumer 3, they cannot connect to this partition from consumer group ID 2. And consumer 2 from consumer group ID 2, it is consuming the message from partition 1. It means the consumer 1 and consumer 3, they cannot connect the messages from partition 1 from the same consumer group ID. And from the same consumer group ID, consumer 3 is consuming the message from partition 2. It means consumer 2 and consumer 1 of same consumer group, they cannot consume the message from partition 2 because already one consumer is consuming the messages. Remaining two consumers of the same consumer group, they cannot consume the message from the same partition. Now let's come to consumer group 3. So this consumer group, by using this group ID, only one consumer is connected from one of the application servers. Now only one consumer, see, it can consume the message from partition 0, one consumer, and it can connect to the message from partition 1 and it can connect to the message from partition 2 also. If we have another consumer, then it cannot consume the message from the partitions with the help of consumer group ID 3. It cannot because already one consumer is connected. As it is only one consumer which is doing same consumer group ID, so it can consume from this partition. It can consume from this partition and it can consume from this partition also. If we have more consumers in a single group, it means more consumers in one single consumer group, it means that, okay, then the partitions, then some consumers of the same consumer group will be inactive. See this point. If we have more consumers in a single group than the available partitions, which means, for example, there is a consumer group. In this consumer group, let's assume there are 5 consumers. So consumer 1, consumer 2, consumer 3, consumer 4, consumer 5, right? So one consumer group and 5 consumers are using same consumer group ID. So one consumer number 1 is consuming the message from partition 2 and consumer 2 is consuming the message from partition 1 and consumer 3 is consuming the message from partition 3. It means there are 2 remaining consumers, right? They will be inactive because they won't connect to these partitions, right? They can't. Already all the 3 partitions are occupied by all the 3 consumers. So remaining extra consumers, they have to be inactive. That's it. So Kafka guarantees that message is only ever read by a single consumer in the group. So what Kafka will do is, whenever a consumer consumed the messages from a consumer group from a specific partition, the another consumer, it cannot consume the message again because already this group, whenever a group message got consumed by a group ID, it means it will make a commit entry in Kafka. Now any another consumer freshly connect to the same partition and try to consume the message from the same partition, Kafka will have an entry. Boss, already one consumer is connected by using this group ID. Now I can't give you the messages. So that's what Kafka will do. Kafka stores the offset at which a consumer group has been reading. For example, see, the offsets committed live in Kafka in a topic called __ consumer _ offsets. Whenever we have started a Kafka cluster, right? The Kafka cluster automatically creates a topic called __ consumer _ offsets. So this is completely managed by Kafka cluster itself. We do not have any control over this particular topic. Now, in this topic, what it will do is, whenever any consumer is consumed the messages from any partition by using a consumer group ID, now in this topic, Kafka makes the entry, Kafka makes a track, okay, this particular consumer group has consumed the messages from this topic partition. It means whenever any new consumer is consuming the messages from the same partition by using same consumer group ID, I should not give that message to that particular consumer group because I already have the entry in this topic. So to straight away to give an answer to your question, whenever a consumer group ID, a consumer consumed the messages with the help by using a consumer group ID, in Kafka, this consumer _ topic makes a track. Okay, this consumer group ID already committed these many offsets in my partition. So this will be tracked by this topic in Kafka. For example, whenever a consumer group has processed the data received from Kafka, it should be committing the offsets in this topic. So whenever any consumer group has processed the data from Kafka, so Kafka will make an entry. Okay, in this consumer group has consumed these many offsets from these many partitions. So that's how Kafka behaves. For example, and what is the advantage of consumer offsets? Very simple. See, for example, there is a consumer from consumer group. It is consuming the messages. And if you see 4258 is an offset, 4259 is an offset, 4260 offset, 4261 offset, till 4269, these are the offsets. Okay. Now the thing is, a consumer, it is using a consumer group ID and it is consuming the message. For example, first it has consumed the message from offset number 4258. So this topic in Kafka will make a track in this topic. Okay, 4258 is already consumed by this consumer group ID. Now 4259, it will make an entry here. 4260, it will do commit here. 4261, message got consumed, so it will make a commit here. It means Kafka. Now 4262 successfully successfully read. It means Kafka will commit that message in this, it will make an entry like this message, this offset has been committed. Committed means successfully processed. Now 4263, let's assume the data is being read. Process is not completed. A consumer, by using consumer group ID, is consuming the messages, and all of a sudden, due to some network glitch or due to some any issue, the consumer died. Consumer died. Okay. Now Kafka have an entry that, okay, this consumer group already committed till offset number 4262. Now let's assume the consumer after 3 minutes again it came back and it is again try to consume the messages from the topic. Now instead of, it is using this consumer group. Now instead of consuming the messages from the beginning offset, from the first offset, what Kafka will do is Kafka will first go to this topic and it will verify, okay, this consumer group ID committed till which offsets it is committed till offset number 4262. But 4263, it is still uncommitted. Fine. So let's give the message from this 4263 offset. Now 4263, 4264, 4264, everything will be committed as soon as messages are consumed. So the advantage is going to be whenever a consumer, all of a sudden consumer dies or disconnected, whenever it is connected back, so the message will be consumed from where it left off instead of consuming from the beginning offsets. That's the advantage of using consumer group. Kafka will make an identity. Okay, this consumer group has consumed till here. Whenever this consumer connects from connects again after a few minutes, after a few days, with the help of same consumer group, now I have to give the message from this particular offset only, because Kafka now have something called committing in consumer offsets. So that's what the advantage of consumer offsets. That's what the advantage of committing the offsets with the help of consumer group. Okay, so this is completely internal, so you no need to worry about it. So this is completely thing. Only the thing is the consumer in real time, they definitely use consumer group. And no consumer will connect without an identity. They definitely use a consumer group ID. So let's talk about something called ZooKeeper. So ZooKeeper manages brokers. So ZooKeeper is altogether a different concept. So simply we can say ZooKeeper manages your Kafka brokers. ZooKeeper performs leader elections for partition, and ZooKeeper sends the notification to Kafka in the case of changes. For example, when you create any new topic, when a broker dies, when a broker comes up, when you delete topics, so everything will be managed by ZooKeeper. Simply you can say ZooKeeper manages your Kafka cluster, and without ZooKeeper, there is no Kafka. Okay, the thing is, in order to create a Kafka cluster, first of all, you have to start the ZooKeeper in your Kafka cluster. So Kafka cluster is always a combination of both ZooKeeper and Kafka. Then only it is called as a perfect Kafka cluster. If you want to start Kafka cluster without ZooKeeper, no, there is no possibility. You must have the ZooKeeper, because ZooKeeper manages a distributed platform. Okay, so simply we can say Kafka cannot work without ZooKeeper. And ZooKeeper by design operates with odd number of servers. For example, I have decided I want to have a Kafka cluster in the production environment. Now, before deciding Kafka cluster, how many rows it should have, first of all, you have to decide how many ZooKeeper quorum you should have, like how many ZooKeeper servers you need to have in the Kafka cluster. And by default, I mean, generally, ZooKeeper should always have an odd number of servers. Like in your Kafka cluster, you should have 3 ZooKeeper servers, or should have 5 ZooKeeper servers, or should have 7 ZooKeeper servers. That you need to decide. Like in the multi-node Kafka cluster, we are going to discuss about the importance of a ZooKeeper. So not right now, but right now blindly you can remember, without ZooKeeper, Kafka cannot work. As simple as that. So ZooKeeper is also having something called a leader and the follower, which means, for example, in my Kafka cluster, if I have created a 3 ZooKeeper program, out of 3 ZooKeeper servers, 1 ZooKeeper will be leader. Remaining 2 ZooKeepers are going to be the followers of this particular leader ZooKeeper. And what is the advantage with this leader ZooKeeper and follower ZooKeeper? We are going to discuss in the multi-node Kafka cluster. So, for example, if someone has given me a task, hey, please set up a Kafka for my development environment. So in development environment, how do you do? So the thing is, in development environment, we are going to set up a Kafka as a single node installation. It means in our Kafka cluster, only one Kafka broker is going to be installed. For development environment, that is fine. And this is the basic setup. Okay, so today what we are going to do is, we are going to take a Linux server, and inside that Linux server, we are going to install Confluent Kafka 6.2 version, which is the latest version. So here we are going to install Kafka 6.2, not 6.1, because 6.2 it came recently into the market, very latest version. So let's go with that. Okay. All right. This is the documentation. And before going to the documentation, let me switch on my Linux operating system. Like in my Windows machine, to configure a Linux, first of all, I have installed a VMware Workstation operating system. VMware Workstation Professional. And inside this VMware, I have installed Linux operating system. So this VMware software and then Linux ISO image, everything I will provide you as a Google Drive link. Okay. At the end of the session, I will show you how you can install VMware, how to download Linux operating system, how to install Linux in the VM, and how to install Kafka. Everything I will show you. So I'm powering it on. So now my Linux operating system is getting started. Let's wait for a few minutes. See, it is asking me the log. So I'm logging as a root user. So this is my operating system. I am the one who installed it. I know what is my root user password. So I'm logging as a root user. I hope you know what is my root user in the Linux, right? Now my operating system, my Linux operating system is on. Now I have to take the SSH. To take the SSH, we need to have the host name, or we need to have the IP address. So let's have the IP address. We'll take the SSH with the IP address. So if I type the command called ifconfig, we will get the IP address, which is 192.168.136.128. Now to take the SSH, I will open mobile system. Now I will click on session. I will click on SSH. I will go 192.168.136.128. Perfect. When I click OK, now it is asking me login as. I will log in as root user because I know the root password and I'm entering the password. Perfect. See, this is my Linux operating system. If I do uname, so this is my Linux operating system, which we have switched on from the VMware. So before going to discuss further, first of all, let me do some cleanup because already Kafka is there. So let me do some cleanup. Let me make it as a fresh machine. Now there is nothing. It's a fresh machine. Now let's start with the installation. So I have a Linux operating system and this is my Linux operating system. Now I want to install Kafka as a single node in this machine. So the procedure would be very simple. In this machine, we need to download Kafka software and then we need to start ZooKeeper and then we need to start Kafka. That's it. It's only 3 steps. So the thing is, before installing Kafka, we have to check some prerequisites. The thing is, when we try to install any software in the real-time servers, definitely we need to check the prerequisites, right? So same like to install Kafka, there are around 5 prerequisites, and let's check all those things. The first thing is you need to have Linux 6 or Linux 7 operating system, right? So the thing is, right now we have the operating system, and in order to check what is the version of my Linux operating system, there is a command called cat etc Red Hat release. So I have installed Red Hat Linux operating system. So this file will be there. If I hit enter, it says Red Hat Enterprise Server 7.3. Means my Linux is a Linux 7 version, which is perfectly fine. Now let's come to the second one, the RAM and hard disk. In your Linux operating system, you need to have minimum 6 GB and 500 GB of hard disk, right? So real time, definitely we go with the 200 GB hard disk or 300 GB of hard disk, so which is fine. So, but to install content Kafka 6.2, minimum 6 GB is more than enough. And the hard disk is going to be 500 GB. But in the real time, definitely we use terabytes of hard disk in Kafka, because the purpose of Kafka is it has to store, really huge, tremendous volumes of data. So it will having, around 2 TB, 3 TB, 10 TB hard disk also. But here in our mission, if I want to check the RAM size, there is a command called free minus h. If I hit this, the memory, you see, right now there is a 2 GB RAM in my virtual machine. This is my Linux operating system. I have given 2 GB RAM, and out of 2 GB, 1.5 GB is free. So for our testing purpose, for our training purpose, this is more than enough. And if you want to see the hard disk size, if I do df minus h, and it is a 20 GB hard disk. If you see this root file system, total thing is 20 GB, 18 GB. Out of 18 GB, 15 GB is free. So we are not going to handle a tremendous volumes of data because there is no real-time data in our mission, right? So which is fine. 84% is, oh, sorry, out of 18 GB, 15 GB is used and 2.9 GB is available. So this is more than enough for us because we don't put any real-time data. We're going to put our test images only, which is perfectly fine. All right, fine. And there should be something called a specific service account, a specific user account for Kafka. For example, in this case, I'm taking a user called Kafka, right? But in our case, instead of Kafka, we'll go something called a user called Ratnakar, because the thing is, in my mission, I want to start my Kafka as a user called Ratna, right? So what I will do is I will create a user called Ratna. And because I have decided that my Kafka should run as a Ratna. So you can use any user. It's absolutely no doubt at all. There is no specific rule that Kafka should run only with this user, then only it will work. No, there is no such kind of rule in Kafka. You can use any user. So in this case, I am using some user called Ratna. Okay. So first of all, if I want to check that particular user is there or not, if I do ID space Ratna, see that particular user where you want to run Kafka, that user is not there. So first of all, we have to make sure that particular user is there. So in the real time, generally we don't have the root user access. So what we'll do is we'll create a request. We'll open a request to Unix team so that they will create the user on our behalf, and we can get the sudo access for that. But in this case, this is our operating system and we have the root user privileges and we know how to create the user. So this is the command user add and then the username, so that that particular user will be added. For example, if I say user add and then what is the username I want to add? Ratna. See, no errors. If I do Ratna, see, now that particular user is there. Previously, before executing this command, when I say ID Ratna, that user is not there. But now I can see that particular user is there. Okay. Now switch to Ratna user using su minus Ratna, so that you will be switched as Ratna user. See, who am I? So I'm logged in as a Ratna user now. Now I'm not a root. I have logged in as a Ratna. If I do pwd and I am in the home directory of Ratna. Now the fourth prerequisite is we need to have a specific file system, one for ZooKeeper and one for Kafka. The thing is, when we want to install Kafka, so we need to have ZooKeeper and then Kafka. Kafka cluster is combination of both ZooKeeper and then Kafka. This one we have already discussed in the previous session in our technical introduction session 2 part, right? Without ZooKeeper, Kafka cannot run. So the thing is, when you want to install Kafka in a single node, in one machine, in one node, you need to have ZooKeeper and Kafka running on the same machine. So the thing is, for ZooKeeper, we need to have one file system, and for Kafka, we need to have another file system. So in this case, what I did is, so I created a separate directory called data. Under root directory, I have created a directory. Okay, let me do one thing. Let me delete and let me recreate. Okay, let me go to user. CD slash. There is a directory called data. Where is that? Okay, see, here it is. So let me remove it. Remove rm minus rf data rm minus rf data. What is there? I don't need this. Perfect. Now let's create a separate file system called slash data slash ZK and slash data slash Kafka. Slash data slash ZK is for ZooKeeper and slash data slash Kafka is for Kafka file system. So to create the file system, again we need to have the root user access, right? So in the real time, generally we have to submit a request to Unix team so that they will create the file system and they will allot some space to that. But in this case, I'm going to create myself. So mkdir -p slash data. So first of all, ZooKeeper file system slash ZooKeeper. And then I'm going to create another directory, another file system for Kafka. So mkdir -p slash data slash Kafka. It means under data directory, now data directory is created. Under data directory, there are two subdirectories. One is ZK, one is Kafka. ZK is to hold the ZooKeeper related data. Kafka is to hold the Kafka messages. For example, if any developer, if any client connected to Kafka and published any message to our Kafka cluster, that message will be physically stored in this file system. That is the reason we need to have this particular file system. For example, if I do df -h now, sorry, if I go to cd slash and if I do ls -lrt, now see there is a file system called data. And if I do ll/data, under slash data, there are two directories, Kafka directory and then ZooKeeper directory. But the problem is the data directory is having root permission, right? But this data directory is meant for our Kafka related stuff, right? The thing is we need to change the ownership of this particular directory as our Kafka service account. The thing is, in this case, we have already decided Ratna is going to be our Kafka service account, which we have created here, right? So here we have to change the permission of slash data to Ratna, because the user Ratna, he should have the permission to access this particular file system. When it is having root file system, so your Ratna user cannot access this file system. So let me change the ownership also. So chown as a root user, chown -r, and then Ratna is the user and Ratna is a member in Ratna group, and then give your data. It means for the data directory, the ownership is going to be changed from root to Ratna, and then inside the data directory, all the subdirectories will also get the same permission because we are giving -r here. Hit enter. Now see cd slash ls -lrt. Now see the data file system, now permission has been changed to Ratna. It means Ratna user can access these file systems now, right? And also if I go to data, inside this data, see the ZooKeeper directory and Kafka directory is also having the permissions of Ratna and Ratna. Perfect. Now in the file systems also, we are good. But in the real time, we have to make sure this Kafka file system should have really high memory, high space, around, depends on your application requirement. For example, your Kafka is going to hold really huge, tremendous volumes of data. So a lot of 1 TB of data or 2 TB of data. So that is the thing we have to take care. But in this case, if I do df-h/data/Kafka, Kafka is having how much size? It is just more than root file system only. So which is having 2.9 GB, which is more than enough in our test cases. But in the real time, you have to make sure there should be enough data. This is the fifth requirement. Now, see, if you see here, a file system minimum 100 to 300 GB. You need to have this. Perfect. Now we can start with the installation procedure. Okay. So before starting the installation procedure, let me explain you what we are going to do exactly here. The thing is, installing Kafka, I mean, for a successful Kafka run in your machine, we need to do 3 steps, only 3 steps. So when you do this below 3 steps, that's it. Your Kafka will be up and running. The first step is you need to have Java 1.8. This is minimum. So because without Java, Kafka cannot run. Because we already know Java is already developed on, Kafka is already developed on Java and Scala languages, right? So without Java, Kafka cannot run. So first thing is you need to have Java associated for your service account. We need to have Java 1.8 installed in your Linux machine for that particular service account. And then the second step is Kafka installation. This Kafka installation will include 2 things. Number 1, ZooKeeper setup, and then final setup is Kafka setup and start. So when you do this, step number 1, and then step number 2.a, step number 2.b. When you do all these 3 steps, it means you have successfully started Kafka, and Kafka is successfully running as a single node server in your server. Okay. So and here are the steps. So first of all, so here Java 1.8 I have given minimum, but now the latest Java version is JDK 16.01. Okay. So first of all, before installing this, before setting Java for your service account Ratna, first of all, let me switch to Ratna user account. So su-ratna, and if I do Java minus version, Java-version command, right now see Java command is not found for your Ratna. It means Java is not at all installed for Ratna. Ratna user not able to identify what Java component is it has to use because it's really a fresh machine, nothing is there. So first of all, we have to set the Java, right? So to set the Java, the thing is we have to, so this is the URL to download the Java. So let me open this. So I'm clicking on this URL. So it will redirect me to Oracle website because now Java is maintained by Oracle. See, Java SE6 we are using. Now there is something called JDK download in this machine in here, right? Just click this so that it will redirect you another page. Here you can see Java SE development kit 16.0.2. So we are using a Linux operating system, right? So we have to download appropriate package. Here we are using Linux ARM, Linux ARM64, Linux Debian package, Linux RPM package, Linux 64 compressed archive, Mac operating system, Windows operating system, all the operating system Java you can see. But here we need to have this one, Linux 64 compressed archive, a tar file we need to have, right? So just click on this. So and then click this box and then click on download Java JDK 16.2 so that JDK will start installing. The thing is, initially, it will ask for the login. Like for example, I have already logged into my Oracle website. By default, at the backend, it will take my Gmail account and my credentials so that it is getting downloaded. But you don't have any account with the Oracle, right? First of all, it will ask you, first of all, please sign up with the Oracle. So you just have to sign up and you have to fill some details like your name, email ID, mobile number, something like that. And then you have to sign in. So automatically it will start downloading. So that is the only thing you will ask. But in my case, I have already logged into Oracle website. That is the reason it is right away it is downloading this. So right now I'm canceling this because in my system I have already there. So in my Windows machine, if I go to F drive, in the F drive there is a Java directory. Inside Java directory, you see here JDK 16.1 I have already there. Now the thing is I have to get this software into my Linux operating system, because I need to install in my Linux operating system, right? To get that software in the mobile system, what I will do is there is something called sessions here. No, not sessions. There is something called SFTP here. Click this and then get it to some location. Here I'm getting this software into home location of Ratna user, which is /home/Ratna. Click enter. So this is the home directory of your Ratna user. For example, if I do cd enter here, now see I am in the path of home Ratna directory. If I do ls-lrt, right now there is nothing. Right now I will upload my file into this particular file through this SFTP option in MindMajix. So I will click on this upload button and then I will go to F drive, Java directory. This is the software. This is the Java 16 version. Click open. So that, see, it is now uploading. You see the progress here. So when you see 100%, it means your Java will be uploaded. So let's represent that. Fine, 100% completed. Now I can see the entry here. And also, if I do ls-lrt here, see, now I can see the thing. But the problem is it is having root ownership, right? Let's change the, no, I think that is fine. Let's leave it like this. I think we can extract. Fine, we have the software available now in our Linux operating system. Now, after downloading the software, what we have to do is we have to gunzip the software, right? Here you see the extension, it is a gunzip file. Now I'm directly untarring it using a command called tar-xzbf and then your file name. Hit enter so that a separate directory called ZDK1601 will be created, and inside this directory all Java binaries will be created. Now if I do ls-lrt, now see there is a directory called JDK1601 has been created. Now if you see the ownership, Ratna is having the ownership, which is perfectly all right. Now you this file is no more needed. This tar file is no more needed. You can delete it. Enter. Yes, I want to delete it. Perfect. It's now deleted. Now we have only Java directory. So now when we extracted, it means Java has been successfully installed. Java installation is done. But the thing is, we have to configure this Java to be understandable, to be readable by my user called Ratna. Although Java is installed, if I do Java minus version, still it is saying Java command not found. Because although you have installed Java successfully, but you have not configured Java in a proper way, and that should be recognized by your user called Ratna. Ratna user not able to recognize where are your Java binaries. So we have to set that. When you set that, that's it. Your Java part is done. Now the thing is, so we have to open the bash profile of Ratna user, and then we have to set the path like this, so that every time when you log into Ratna user, this bash profile will be loaded, and then your Java binaries will be identified. For example, if I do ls-lart, there is a bash profile for Ratna user. Like if I open bash profile, perfect. So in the path, right, what I will do is I will just give this thing. Copy and so I will remove this. See, I am exporting my Java path. So my Java is in home. Okay, it is not in home Kafka. It is installed in home Ratna, right? So we have to make sure the user path. In Ratna, there is a person called there is a directory called JDK1601. Inside this directory, there is a bin directory, and inside this bin directory, there is the path. Now save the file. Now what we have to do is we have to source this file. Source means whatever the content that is there in this bash profile, that will be executed once. So right now I am not sourcing. Before sourcing, if I do Java minus version, which is still command not found, but now I am sourcing it. Source dot bash profile, so that whatever the content you have uploaded in this thing, that will be sourced. Now see, Java minus version. Perfect. Now see, Java command is working because we have given the path, Java installation path in our bash profile, and then you have sourced your bash profile so that now this Ratna user will know, okay, this is my Java. Now Java is executable with your Ratna user. For example, every time if I switch to Ratna user, by default this bash profile will be loaded and this Java path will be set, and your Ratna user will identify the Java. For example, again I'm switching to root user. Now see, if I do Java minus version, see, Java is not identified by root user because in the root user bash profile we have not set the Java path. So root user doesn't know. So whenever root user loaded, it has loaded the bash profile of root user. But in the bash profile of root user, there is no details we have given for Java. So it is not working. But if I switch to Ratna user, when we are executing hyphen symbol here, it means the bash profile and bash RC both will be loaded. So whatever the things you have given, whatever the path you have exported in the bash profile, that will be automatically loaded. For example, if I hit enter, oh, typo mistake, RATNA. Right. Now, if I do Java hyphen version, see, but with Ratna user, my Java is working because I have set the bash profile in a proper way for that. Done. Perfect. Now Java is done, right? Now, after installing Java, now we are jumping into main thing, which is Kafka installation. Kafka installation. Kafka installation consists of two things. Number one, ZooKeeper setup, and then Kafka setup. So first of all, let's set up with the Kafka. Let's set up with the ZooKeeper setup. So to install ZooKeeper, so we'll do one thing. So there is a direct URL here. So we are downloading Confluent Community. Here it is 6.1 link. I think right now this link won't be available because right now the latest version is 6.2. Let me do one thing. Instead of hitting this link, I will do one thing. I will go to google.com. I will do Confluent Community. Community means it's a free version. So Confluent Community install. That's it. Just type like that. And if you just scroll down, yeah, there is some link called manual installing using zip and tar archive, which is a Confluent documentation. Let's click this. This is the right link where we have to go. Now, this is a Confluent page. Now, in this, there are all the things will be there. So, Confluent installing using zip and tar archive. And if you click here, it's a Ubuntu and Debian packages. If you need to install on Debian packages using apt-get, this is the thing you have to use. But for RHL and CentOS, this is the process. Our thing is ours is your RHL, right? Our Red Hat Enterprise Linux, and this is the system. This is the thing what we need to install. But here RHL, it's a system D. We don't need system D. I think we'll go to zip and tar. Yeah, perfect. See, there are two things. To get the software, Confluent platform will be there, on Confluent platform using Confluent community components. The thing is, we need Confluent community components, which is a freeware, which is a open source. Okay, so if you see the tar file, there is a this is the URL link. You see the URL is 6.2, which is the latest version. So for example, if tomorrow Confluent releases its communication 6.3, then automatically this link will be updated as 6.3. So they will update it. So what I will do is, I will copy this link from HTTP, and in the browser, I will paste that. That's all. So that, see, Confluent community tar is getting downloaded. Now in my Windows machine, in my system, I'm downloading my Confluent community. But right now I already have this software in my machine, so I'm canceling it. So if I go here, if I go to F drive in my computer, F drive, Kafka, I will go to Confluent directory. In the Confluent directory, you see there is a tar Confluent community 620. So I already have downloaded it. Okay. So now let me get this tar package into my Linux machine using SFTP. So again, I will click on SFTP option, and in the home directory, I will upload my Confluent platform. So Kafka, Confluent 620, and then okay. So that will be uploaded to my Linux operating system. So it is getting uploaded. Let's wait till it completes 100%. Perfect. Now 100% is completed. And if I do refresh, see, I can see the software here. Also, if I do ls-lrt, see, I can see content community 620 tar.zz. Okay, fine. We have the software now. So after getting the software, what to do? The thing is, you have to extract it using tar-xzbf. Okay, here see it is a content from 5.5 I have given. It means the documentation is pretty old, but just you have to change the versions. That's it. So if I do tar-xzbf and then type this tar file, so that conflict community installation will start in this mission. All the needed packages will be extracted. Now see a directory called confluent 620 will be installed, and inside this directory, all the related confluent components, which includes Kafka schema registry, then a lot of components will be there, right? Everything will be installed. Now Kafka installation is going on. Perfect. So installation is done. If I do ls-lrt, now I see a directory called confluent 620. So once the installation is done, you can remove this tar file. I don't need this. Done. Now see, I have confluent 620. Now installation is done. Now the thing is, you have to start it. You have to configure the things, and then you have to start. But before configuring the things, let me go inside this directory. Let me see what this directory is having. So if I do, okay, right now we are inside confluent 620 directory. If I do ls-lrt, see, there are some directories: share, lib, etc, bin, source, readme. So as of now, what we need is we need etc directory, and then we need bin directory. So in the bin directory, the Kafka binaries will be there. For example, if I go to bin directory, now we are in the bin directory. If I do ls-lrt, if you see here, let me do one ls. If you see here, there are so many commands. All these are Kafka commands, right? So when we go forward, we are going to discuss all the needed commands which are needed for our Kafka administrative perfect. For example, if you see here, Kafka server start, this command will be used to start Kafka server information. Kafka server stop, if you want to stop Kafka, this is the command. Kafka topics, if you want to create a topic, this is the command. And then ZooKeeper server start, if you want to start the ZooKeeper will be there. If you want to stop the ZooKeeper, this is the command. So the thing is, the confluent community that will include both Kafka related things and then ZooKeeper related things, because without ZooKeeper, Kafka never work. Okay, now we have the binaries. Perfect. Now I am coming out from the bin directory. If I do ls-lrt, and then there is a etc directory. This etc directory will be having the configurations for both your Kafka and ZooKeeper. For example, if I go inside this etc directory, now we are inside etc. If I do ls-lrt, and then there is something called Kafka directory. Right now, just to go to Kafka directory, forget about the remaining other directories. cd Kafka. Now we are in etc Kafka directory. If I do ls-lrt, you see there are so many properties files, right? So right now we need only two properties. One is ZooKeeper properties. Second thing is server.properties. So this ZooKeeper properties will be contain the configuration details of your ZooKeeper. Like if you want to configure your ZooKeeper, if you want to start your ZooKeeper, what is the configuration parameters you have to invoke? So, and this file will contain my ZooKeeper configuration details. And then if you go to server.properties, so if you want to start Kafka, what is the configuration parameters you need to invoke? Those parameters, those configurations will be in server.properties file. Okay, so right now we need to we need to look for the ZooKeeper properties, because after installing Kafka, the first step we need to do is we need to start the ZooKeeper, right? So the thing is, okay, now in order to, okay, now we have extracted our content community platform. Now the thing is, we have to go to the Kafka directory and we have to open ZooKeeper.properties file, because in order to start the ZooKeeper, you need to modify something in the ZooKeeper properties file. The thing is, this ZooKeeper properties right now we have straight away downloaded from the Confluent website, and this will be common. This will be having some common properties, but we have to customize it according to our business requirement, right? So let me open this thing. If I do view ZooKeeper properties, see, so this ZooKeeper properties will be having few things. This property file is very simple. If you see the first line, licensed to Apache Software Foundation. So by seeing this line, you might be confusing, right? And it is showing the Apache license also. Here, the thing is, we have downloaded Confluent related Kafka, which is Confluent Community 6.2. But now why it is reflecting Apache license? The reason is very simple. Confluent developed their Kafka on Apache binaries only. Okay, so if you are learning Apache Kafka, if you are learning Confluent Kafka, both are same, absolutely no difference. When I open ZooKeeper properties, if you see the first line, licensed to Apache Software Foundation. The thing is, here we have downloaded Confluent software, but Confluent software, it is showing Apache license thing. Why? Because Confluent developed the Kafka by inheriting the Apache Kafka only. So Apache Kafka, Confluent Kafka, both are same, absolutely no difference. But the only thing is Confluent is having its own features and Apache is having its own features. That's it, nothing else. But the technicality wise, procedure wise, commands wise, everything is same. No difference between Confluent and Apache, both are same. Okay. Okay. Now in ZooKeeper properties, we need to understand about the first property, which is data directory. In the data directory, this data directory means the ZooKeeper data will be stored in which directory. So that part, it will be by default, it will be having something called /tmp/ZooKeeper. But here we need to have our customized thing, which is /data/ZK, because in the prerequisites, that is the file system we have created for ZooKeeper. So that when you start ZooKeeper, it will make the entries in this file system for your ZooKeeper. And the client port is 2181. So always the ZooKeeper default port is 2181. So if you want to change the ZooKeeper port, you can change it. You can change it here. For example, if I want to use something called 1923, you can definitely use this. But don't change it. Put it like 2181 because it doesn't make any difference. Even in the real time also, we mostly go with the 2181 only. So let's put ZooKeeper port as 2181. And then maximum client connections is equal to 0. It means that at a time, how many maximum clients can connect. So for example, if it is having 1, it means only 1 client can connect at a time. If it is having 4, it means at a time only 4 clients can connect. If it is having 20, it means at a time only 20 clients can connect to Kafka. But generally we put it as 0. 0 means infinity clients can connect to this Kafka cluster at the same time. And this is the recommended way. Always use max client connections is equal to 0, because in real time, the meaning of Kafka is it has to handle many connections, billions of connections at the same time. Because the purpose of Kafka is that thing only. It has to handle really tremendous of data from millions of applications. So always put it as 0. Don't try to change it. Okay. Yeah. So that's all for now. Now I'm saving the file. WQ exclamatory. Now let me cat and see the properties. For ZooKeeper properties, if I cat it, the one we have changed is data directory, data ZooKeeper, and then client port 2181, we have not changed it, and then maximum client connection, we have not changed this. Perfect. Now what to do next? The thing is, when we set the data directory, now we are ready to start the ZooKeeper. Perfect. Now we can start the ZooKeeper. But before starting the ZooKeeper, let me show you one thing. If I go to /data/ZooKeeper, if I do ls-lrt, right now there is nothing inside data ZooKeeper file system. Now let me start the ZooKeeper and then let's see what happens. Now the thing what we have to do is, okay, we are ready to start the ZooKeeper. So the thing is, we need to go to the binary directory, because in the binary directory only we have this ZooKeeper start command, right? So the thing is, right now, okay, we are already into the bin directory, right? So in this bin directory, there is something called ZooKeeper server start. So this is the file, this is the command what we need to use to start the ZooKeeper. So the thing is, to start the ZooKeeper, the command look like this: /. Always when you execute any command, right, you have to execute as a shell script. So ZooKeeper server start and then space. So whenever, okay, let's hit enter. Let's see what happens. If you see here, whenever I hit when I execute this command and when I hit enter, it is showing me, hey boss, your command is wrong. The usage of the command is ZooKeeper server start, and then you have to use ZooKeeper properties. You must invoke the properties of ZooKeeper, because this properties file we have given the configuration details, right, about the file system, about the client port, about the maximum client connections. So now Kafka will always refers to this properties file, and in this properties file, how you did the configuration based on that your ZooKeeper is going to behave. So the command look like this.
Yeah,
so let's go to etc Kafka. Here we have the ZooKeeper properties. If I do ZooKeeper, so these are the properties. Here we have given only 3. So this one we have changed, data directory 1, and then client port, and then maximum client. But this client port, maximum client, we no need to change, because this is a ZooKeeper port, which is okay. Even in real time also we use 2181 only. And maximum clients, always highly recommended put it 0. It means infinity clients can connect it at the same time.
Yeah.
For example, if I do ls minus lrt, Kafka is having something called server.properties.
Oh, in the
So if I open the server.properties file, there is something called port number. Okay, port number is not there in Kafka, but by default Kafka will run on a port called 9090. If I go up, see, there is something called listeners. So we have to enable this property in Kafka. Now Kafka will start listening on 9092. 9092 is the default port for Kafka. So if any application wants to connect to Kafka, if they want to publish the message, they have to use this port number. So right now we need ZooKeeper only. Perfect. Now to start the ZooKeeper, we have to go to the bin directory. So the bin directory is just to go 2 steps back and then go to bin directory. Now we are in content bin directory, ls minus lrt, ls, and there is something called ZooKeeper server start. So / ZooKeeper server start, and then we have to invoke our ZooKeeper.properties file, because I want to start ZooKeeper. So our ZooKeeper properties file is in home, Ratna, Confluent, and then etc Kafka ZooKeeper properties. So always recommended thing is we have to give the entire absolute path. Fine. So if I hit enter, now ZooKeeper will start running. See, now you are seeing something on the screen, right? Now it means some logs are recorded for ZooKeeper, and there is something, if you see this line, info binding to port 002181. It means your ZooKeeper has been successfully started and it is running. All right. Yeah. Now ZooKeeper is perfectly running. But the thing is, here right now the control is still not in our control. I mean, the control is not released to us, because we have started our ZooKeeper as a front end. For example, if I just scroll up, okay, here is the thing, here is the place where we have executed the command. Now logs are starting recorded. Now see, it is invoking the reading the configuration from ZooKeeper.properties file, and then this is the client port 2181, and it is doing something, some backend checks, it will do something, and in the bottom of the line it will show you info binding to port 2181. But still the control is not in our hand now, because we have started it in the front end. So it is starting in the front end. So the thing is, let me do one thing. If I open the duplicate session, so same server, I am taking a duplicate session. So let me log in as root. Now let me switch to user called Ratna. Okay. Now if I do ps minus ef Kafka, see, now something called running, ZooKeeper is running. For example, if you want to see if Kafka and ZooKeeper running or not, you have to use a command called ps-ef Kafka. That's it. Now ZooKeeper is running, because I can see the process with this ID, right? And ZooKeeper is running as Ratna user. So ZooKeeper is running. We have started only ZooKeeper with this properties file, and it is running fine. But the problem here is, here in this screen we have started ZooKeeper as a front end. Whenever we close this session, right, ZooKeeper will be auto terminated. It will be auto shutdown. For example, I'm just closing this. So one or more sessions currently running. Do you want to close the session? Yes, I want to close. Okay. Now one session is closed. Now if I do ps minus ef Kafka, you see, is ZooKeeper running now? No, because the thing is, the problem when you start any ZooKeeper process or Kafka process in the front end, it will be applicable to that particular session only. When you terminate the session or when you exit the session, that's it. Your process will be done, which is not at all a good sign, especially in the real time, right? So the thing is, we have to start it as a back end. So starting Kafka in the front end, which is not at all a recommended way, because when you terminate the session, that will be gone, right? But the thing is, we have to start a Kafka process or a ZooKeeper process as a daemon process. A daemon means it's a back end. This is the highly recommended. It means in the back end, your Kafka will be running. For example, now I'm starting my ZooKeeper. So I will go to the bin directory, which is cd home Ratna Confluent bin directory. Now I am going to start my ZooKeeper /ZooKeeper server start. Now I'm starting as a daemon process. Now I'm invoking my ZooKeeper properties file, which is in home Ratna Confluent etc Kafka ZooKeeper properties. So I'm starting ZooKeeper, and this is my ZooKeeper properties. And in between, I am using daemon. In the beginning, we have not used daemon. It means we are starting as a front end. But here I am using daemon, which means I am starting in the back end. It means in the back end, it will keep running. Although you exit the session, it will keep on running. That's the meaning of this thing. If I hit enter, see, now control is released. Now it is not showing you any logs in upfront. Now control is released to you. Now you can type anything, right? But in the back end, I am sure this must have been started. For example, if I do ps-ef Kafka, now see, my ZooKeeper is running. You see, ZooKeeper properties. It means ZooKeeper is now running with this process ID as a Ratna service account. Okay, now it is running in the back end. Although you exit the session, absolutely there is no problem. Now my ZooKeeper is perfectly running, right? But the logs that will be recorded in the back end. For example, if you want to see the logs for this, the thing is, you just come out from the bin directory. Now there is some directory called logs. Okay, go to this logs directory, do ls-lrt. There is something called server.log. This is the file where your ZooKeeper related log and Kafka log both will be recorded in this server.log. So if I do tail minus -f and then server.log, you see, this is the log which we see. This is recorded recently, 6:30. For example, if I do date, now the time is 6:31 p.m. So just 1 minute back, this has been recorded. It means at the back end, our logs will be recorded. So everything will be done in the back end. In the front end, there would be no disturbance. You can do anything. Your ZooKeeper will be up and running forever now. It won't down until you manually terminate it. The final thing is we need to start Kafka. Okay. In order to start Kafka, we have to go to the Kafka directory and we have to open the server.properties in the etc Kafka. So we have to update some properties. So I will tell you what are those. So let me go to etc Kafka. Now we have to open server.properties. Now we don't need ZooKeeper properties. It is already up and running. Now we have to open ZooKeeper.properties. In the ZooKeeper properties, right? So here we need to modify 5 properties. So the first property we need to modify is broker.id. So this is the property file. This is a configuration of a broker that will display what is the broker ID. For example, in the Kafka cluster, the ZooKeeper identify your brokers, your Kafka brokers, not with their names, but with their IDs. So alwaysly broker ID will be having something called 0. If you see, this is the attribute. So the first thing is we have to change this. Okay, let me explain one by one. So broker ID means what is the ID of your broker that is running in your Kafka cluster. So all your ZooKeeper identified your brokers with their IDs only. So this is mandatory. Number 2, log.directory. Oh, hold on. Let me show you one thing. I forgot that. The thing is, before starting ZooKeeper, in the ZooKeeper directory, there was nothing, right? But now ZooKeeper is running, right? So now if you see in the ZooKeeper directory, ls-lrt, there is a directory called version -2. So in this version -2 directory, there are something called snapshot file. So this snapshot always stores the ZooKeeper related data, like whatever the data, whatever the information that is updated, that will be updated in the snapshot.o file. Okay, so right now there is much information. It is just started. So that is the reason it is showing something like snapshot.0, which is fine. Now let me go to Confluent, etc Kafka, and then server.properties. Okay. Now log directory means, okay, where should the Kafka logs should be recorded? So you remember in the prerequisites we have separately created a file system called /data/Kafka for our Kafka file system. We have to mention that. It means whatever the message that being published, that will be stored here. Okay, first of all, let me change broker ID to 1. I don't want to 0. I will put it as 1. And then if I scroll down, there is something called log directory. See, by default, it will be something called /tmp/Kafka logs, but I will put it as /data/Kafka because this file system I have already created for my Kafka. Fine. The next thing is ZooKeeper.connect. Okay. Now the main thing for Kafka is, in order to run Kafka, it has to connect to a ZooKeeper, because without ZooKeeper, Kafka cannot run. Now the thing is, which ZooKeeper server you should connect? This Kafka should connect to which ZooKeeper? So we have to mention that. Right now in this case, our ZooKeeper running on the same mission, right? So always put like a local host. So if I come down, there is something called ZooKeeper.connect. There would be many configurations, will come one by one, but right now, yeah. So ZooKeeper.connect. By default, it will be localhost.2181. And our ZooKeeper is also running in the same mission, in the same local mission as it with a 2181 port, which is fine. But for example, if your ZooKeeper running at something called some 1923 port, you have to mention something called 1923 here. Like in which port your ZooKeeper is running, you have to mention that. But here it is running as 2181. So let's put 2181. Perfect. Now listeners. Now in server.properties file, what this listener will say is at which port your broker is configured. That is what the listener is. Right now, if I scroll up, there is something called listener properties. See, there is something called a listeners. So what this listener will do is, this property, this configuration explains how this broker is configured, at which port this broker is listening to. So let me uncomment this, and always by default Kafka runs on a 9092 port. If you want to change it, you can change it. If you want to put it as 9095, you can absolutely go. If you want to change it something called 1873, that's fine, you can go. But by default, Kafka runs on a port called 9092, right? So just uncomment this, that's it. And the plain text means right now this Kafka is not at all a secure Kafka. It's like a normal, anyone can connect, anyone can do, anyone can publish, anyone can consume, because no security. So that is what the plain text. This is the listener name. Right now your listener name is plain text. Plain text means not a secure port. That's all. Okay, so right now I'm just uncommenting this. I'm putting as 9092 as a plain text. Perfect. Now advertiser listeners. Okay, advertiser listeners, something like whenever any client wants to connect to Kafka, which host name and which IP address they have to use. That is the thing here. So for example, in advertiser listener, whenever any client wants to connect, so they will when they connect to this Kafka broker, right, at the back end, this Kafka broker will give this host name and this port number to client, so that client understand, okay, my Kafka is running on this machine and this is the port, so I have to give that machine. Okay, so right now Advertise the listener, you can ignore. So don't give anything. See, here is the thing for advertise the listener. Right now, don't give anything. So this advertise the listener, I am going to explain in a full-fledged way in the client server architecture setup, not right now. Okay.
Okay.
So right now, forget about advertise the listeners because it is not needed because we have no separate clients, we have no external client, nothing. So forget about advertiser listener. We'll discuss in the client server architecture setup of Kafka about the advertiser listener. All right. All right. Perfect. So we have changed 4 things. Number 1, broker.id to 1, log.directory to /data/Kafka, ZooKeeper.connect is equal to localhost 2181 because ZooKeeper is running on the same host, and then listener is equal to plain text, which means it's a non-secured port, and then the port number of Kafka, which is by default 9092. So advertiser listener, we have not changed it. Forget about it right now. Now I am saving my file. Right. Now let's try to cat the file. Let's verify the things. If I do cat, if I scroll up, so the first property we have changed is hold on. The first property we have changed is broker.id is equal to 1. Perfect. Now the listeners, plain text 9092, which is fine. Now if I scroll down, there is something called a log.directory, which is /data/Kafka, which is perfectly fine. Now finally ZooKeeper.connect, which is here. Perfect. Everything is fine. Now we are ready to start Kafka. But before starting Kafka, if I say ll/Kafka, I want to see what is the content inside /data/Kafka. Right now, nothing. Total files are 0. Right? In data
Yes.
Kafka. All
Yes.
right. Now I am starting my Kafka. So to start Kafka, we have to go to the bin directory /bin. Now see, we are into the confluent bin directory. Now if I do ls, so to start Kafka, there is a command called Kafka server start. It would be here. See, Kafka server start. So the command look like this: /, always use the shell script, Kafka server start, and always use -daemon. Instead of giving daemon, let's start in the front end because I want to show you logs. So I am starting it in the front end. So home, Ratna, confluent, etc, Kafka, and server.properties. We have to give the right properties file. For Kafka, we have to always use server.properties. Now I am starting it in the front end so that logs will be displayed for us in the screen. Hit enter so that Kafka will start. Let's wait. See, now it is reading something in the logs. Now see, some properties are loaded. Now it is starting. Let's wait. Still it is not started. Still it is starting. Still starting. Not started. Hold on. See, now you see this line. Kafka server ID is equal to 1 started. It means now your Kafka is running with the Confluent 6.2 Confluent community service. It's a Confluent community 6.2. Okay. Now this is the broker ID which is started. And if I just scroll up, now let me show you the logs. What happened? Now see, it is registering something. And if you see the first line, info connecting to ZooKeeper on which host, localhost 2181, right? So Kafka, with the help of ZooKeeper connect property, it is trying to connect to this host and it is trying to connect to this port. And this port, it is already identified. So in this port, right now ZooKeeper 3.5 version is running. So here 3.5 is, it's a ZooKeeper version. Okay. And here the host name is mohan1.training.com. So this is my host name, which I have said. So right now you can forget about it. No need to concentrate on this. Now if I scroll down, now see, if you see here, ZooKeeper client Kafka server connected. If you see here, complete with the server. So it has established a session to 2181 port, which is in the same machine. So that it gives some confirmation. Yes, I am able to successfully identify the ZooKeeper on this host at port number 2181. Perfect. ZooKeeper is running. Now it is loading the server.properties file. So server.properties really having so many properties, so many configurations, but here we have given only 4 properties. Number 1, broker.id, which is equal to 1, which has been taken, and then listeners. Come to the listeners. See, listeners is equal to play index 9092. It means this broker is running at 9092, which is a non-secure port. And then log.directory, you see, /data/Kafka, which is taken. And then finally, ZooKeeper connect. If you scroll down, it will be in alphabetical order. So if you see ZooKeeper connect is equal to localhost 218. Perfect. It has taken all the properties, and finally it has come on, and finally it has starting something and doing something, and finally it has started. That's what it is happening. Understand? Now you might be having a doubt if my Kafka is running or not, although it is showing the logs, but these logs are in the front end. So the thing is, as we're in the front end, we can't execute any command here. So I will do one thing. I will open another duplicate session. I will start from there. Let me switch to let me switch to Ratna. And if I do ps-ef5, let me clear the screen first. If I do ps-ef5 grep Kafka, now see, ZooKeeper is running, and now additionally Kafka is also running. Now see, with Ratna there are 2 processes running. One is ZooKeeper process in the machine, in the same machine, Kafka process. It means now Kafka and ZooKeeper both are running in this machine. Now your Kafka single node cluster is up and running. Right?
Right.
Now the thing is, here we have started Kafka as a front end, but if I do Control C or if I close this session, your Kafka will shut down. For example, I'm closing this session. Yes. Now see, if I do ps-ef5 grep Kafka, okay, still it is running, but it will shut down. Hold on. See, now only ZooKeeper is running. The Kafka is automatically shut down because you have started in the front end, and in the front end your connection is gone. You lost the connection. Done. So always highly recommended is start your Kafka as a backend. And to do that, we have to go to content bin directory /Kafka server start. Always use -daemon and then give your server.properties absolute path. Home, Ratna, Confluent, etc, Kafka, server.properties. Hit enter so that all the logs will be invoked in the backend. Okay. Now, if you do ps-ef5 grep Kafka, now see, Kafka is running and then ZooKeeper is running. Now this won't terminate. This Kafka service won't terminate until you manually shut down it. Okay. Now, if you want to see the logs, the thing is you have to go to the logs directory. So go to this Confluent logs directory, do ls-lrt, and then open server.log, which is updated at 648. If I do date, right now 648, it means right now it is updated. So if I do tail-f server.log, see, Kafka is now started, which is this information recorded just now. So always logs recorded in the backend in the server.log. So now we have started our Kafka, we have started the ZooKeeper, we have started our Kafka. Now Kafka is running as a single node Kafka cluster. And if you go to /data/Kafka, before starting Kafka, there was nothing in this file system. But if I do ls-lrt, now see there are 5 files: cleaner offset checkpoint, replication offset checkpoint, metadata properties, log start offset checkpoint, recovery point offset checkpoint. So first of all, I will explain about metadata properties file now today. So if I open this metadata properties file, right now metadata properties is having some data. Remaining all 4 files having not much data. So if I cat metadata properties file, this metadata properties file will be having some details called what is the ID of your broker, which is 1, and then what is your Kafka cluster ID. The thing is, whenever you start any Kafka, right, what the ZooKeeper will do is it will give some name to your cluster, and the cluster name will be added in the metadata properties. And always Kafka ZooKeeper recognize your cluster with this ID. So now in this cluster ID, there is one Kafka broker, which is this one. So with this, okay, we can verify the Kafka like this. And with this, Kafka single node installation is done. So Kafka single node we have successfully installed. So if you want to verify if Kafka is running or not, simply you can say ps-f Kafka and it will show. So that's all. It will show how many Kafka processes are running. Done. Now it's a full-fledged single node. In the development server, which is fine. In your development environment, single node Kafka cluster, which is perfectly. So with this, we have successfully completed the single node installation. VMware Workstation 15. So when you double click this .executable file, when you click next, VMware will be installed. Once that is installed, when you open the VMware, it will ask to enter a license key. So the keys, right? When you click this VMware link, you will have these two things: VMware keys and then VMware Workstation.executable. So once you install, when you open VMware, you just open this keys file. So there are so many queues. All these are universal queues. Most probably the first key will definitely work. If not, try with the second key. If not, try with the second key. But one of the key will definitely work for sure.
Okay.
So once VMware is installed, now it will look like this. So right now I have installed 4 Linux operating system in this virtual machine. That's why in the left side you can see all 4. But in your case you don't see anything. So the thing is, what you have to do is you have to click on create new virtual machine. So when you click this create new virtual machine, now select a typical, click next button. Now there will be 3 things: installer disk image file ISO. I will install operating system later. Out of these 3, select the second one, which is installer disk image. This is a Red Hat Linux ISO image you have to select. For example, in the F drive, you see there is a ISO file called Red Hat Enterprise Linux 7.3 allpcurl.iso. Now select this thing and go to click on browse option. Now you have to select the path where your ISO image file is there. Right now in my case it is in F drive in some MQ directory. Here is the place. Select this ISO image, click open and then click next, and then here you have to give some name, and here we have to give a password. So here the password which you give is, right, it will be a root password, and don't forget this password. If you forget this password, that's all, you can't log into your Linux operating system. You remember initially when we when I boot my Linux operating system, I have logged in as a root user. I have entered a password, right? The password I have entered, whatever the password I have created here, the same password we have to enter there. If we forget the password, this password, that's all. That VM is of no use. You can't log into that Linux operating system. You have to uninstall it. Again, you have to reinstall from the beginning.
Okay.
Okay. So never forget this password. When both passwords are matched, next button will be activated. Now click next. Now give any name. For example, RHEL5. Here I already have 4 RHEL machines. Now I am giving RHEL5 and that will be installed in this location. Now click next. Oh, path already exists. Okay. It means something installation corrected. Now click next. Now see maximum disk. It means 20 GB. So 20 GB of your hard disk will be allotted to this Linux operating system. If you want to put more, you can put 30 GB or 50 GB. But I always recommend go with the 20 GB because for our case, 20 GB is more than enough. So click next. Now, as soon as when you click finish, right, that's all. Your Linux operating system will start installing. That will take minimum around 15 minutes. You'll wait for 15 minutes so that your Linux operating system will be installed and that will be ready. Okay. And after that,
Yeah, right.
you know, right, how to install. You just click on this. Now click on power on button. Okay, it is already running. That's fine. So if I click on RHEL2, so it will come like this. Just click on power on so that it will log in. and you have to enter with the root user, and then you have to enter your password, root password. So that will be in. Now with the help of MobileX, with the help of IP address, just take the SSH. That's it. One more thing. Sometimes there would be firewall issues. Always switch off the firewall. For example, if I do systemctl status firewall D, this is a command to check the status of a firewall. Right now, see, firewall is dead. Let me turn it on. Firewall is starting. If I do systemctl status firewall D, right now firewall is active. It is running, right? Whenever firewall is running through SSH, through MobileX, you can't take the SSH because we have to add some rules in the firewall. But right now in our case, I don't want to add. I will switch. I will turn on the firewall. Okay, using systemctl stop firewall D. This is the command you have to use to stop the firewall. And if you use status again, now firewall is inactive. It's dead. Now you can take the SSH. So don't forget about this firewall step. Now there is something called RHEL2. So let me power on this. I will power on this. So this machine, this Linux operating system, I will use as a Kafka client machine where I can connect to my Kafka server. So it is getting powered on. So let's wait for some time. Yeah. Now it is getting booted. Yeah. Now it is asking me login from it. So I will log in as a root. And I know my root password. Fine. Now, if I do ifconfig, okay, 129 is the IP of my server. Now I will go to MobileX sham. Now what I will do is this 129, I just do double click and it will ask me login from it. So root and my root password. Okay. Now see, the name of this host is mohan2.training.com and the name of this host is mohan1.training.com. So different hosts. Let me do one thing. Let me close this tab. Now let me split the window into horizontal split. Okay, the one you see above, it's a server. The one you see below, it's a client. Because in this mission, the one you see above, which is Mohan 1 mission, if I do ps-ef Kafka, I can see ZooKeeper is running and Kafka is running, which means it's a full-fledged Kafka cluster with a single node. But if I see here in mohan2.training.com, I can see if I do ps-ef Kafka, see Kafka is not running, right? So, but the binaries are I must have already installed. If I switch to Mohan user, cd conflict, yeah. So in Mohan user, if I go to cd bin path, yeah, perfect. But the Kafka binaries are there. You see that? So I have already installed the Kafka and installation Kafka we already know. I have just untagged, I have just to get the tar file, I just untagged it and then I have extracted them so that binaries are available. So now the binaries are available, but Kafka is not running in this mission. Although binaries are there, if I do ps-ef Kafka, but Kafka is not running. It means now this Mohan 2 is a Kafka client machine. But in Mohan 1, the Kafka is running and also binaries are available. It means it's a full-fledged Kafka server. It's a Kafka cluster. So now this Mohan 2 mission developers can use. So they have the Kafka binaries and they can develop their programs and they can invoke their producer and consuming programs in order to connect to this Kafka server. Now the thing is, in order to connect, the first thing is we need to verify if Mohan 2 is reachable, if there is a communication between mohan2.training.com and mohan1.training.com. For example, if I do ping-a mohan1.training.com, yes. Now see, from Mohan 2, Mohan 1 is reachable. This is the IP address. It means now there is a communication between your Mohan 1 mission and Mohan 2 mission, which means communication now successfully established between your client mission and server mission. Correct?
Correct. Yeah.
So in order to establish a communication, what I have done was in the EPC entry, in the EPC host entry, I have made this interface. So Mohan1 with this IP, Mohan2 with this IP, so that this Mohan2 is identifying with Mohan1 with this physical IP. But in the real time, you no need to worry about it. In the real time, your network team will take care of this communication. If the communication is not happening, immediately you have to approach your network team. But the communication is not happening between my client machine and server machine. Can you please check? So that they will verify if any firewall restrictions are there or not. But in this case, I just put etc host interface. Your client should know what's your server host, right? So I manually made it. That's it. So that the ping, the communication, ping -a, if I do mohan1.training.com, from mohan2, I am pinging mohan1. So mohan1 is, it is now I am getting a reply from mohan1, and mohan1 is where my Kafka server is up and running. Right? Now, how the client is going to connect to Kafka server in order for publishing and consuming? It's very simple. Right now from Mohan2, right now I'm in Mohan2. Mohan2 means client, Mohan1 means server. So I am now in Mohan2 mission. Now what I will do is, so I will go to the bin path. I will do Kafka topics -- bootstrap server. Don't do localhost. Here you should not mention localhost. Localhost means locally Kafka is running, that will be available. But in Mohan2, locally Kafka is not running. Kafka is running on where? Kafka server. What is your Kafka server? mohan1.training.com. Now give the proper DNS name and then give your Kafka port number -- list. So this is the thing you have to give. Let's verify that. So you are in Mohan2 and you are trying to connect to Mohan1, which is in 9092. So let's give that. See, we got the topics list. Now client is able to get the topics list from Mohan1. So Mohan1 is a Kafka server, but this command is executed in client machine, which is Mohan2. Correct?
Yeah.
Now, how client will publish? Simple. In their publishing program or in their consuming program, they will. So that program can be developed in any language. It could be Python language, it could be Java, .NET, ASP.NET, C, C++, C Sharp, whatever it is. Kafka have the ability to allow all the applications. It can support all the programming languages. Let's assume they have developed their application in Python. They produce their application in Python program. So in their Python program, they have to invoke a command called Kafka console producer bootstrap server. Now they have to mention the Kafka server name, mohan1.training.com. No more localhost. They have to mention the Kafka server name because it's a client server architecture mode. So 9092 -- topic, say TP1. They're publishing the messages. See, successfully connected. There is a greater than symbol. That's fine. Let's see. One more enter. Yeah. What? What happened? Oh, okay. TP1 is a compacted topic, right? That is the reason it is always expecting key value pair, but the key is null. That's fine. Okay. Okay. Let's do one thing. Let's try to publish the message in a key value pair. Because TP1 is compacted topic, right? Always it will always look for the key value pair thing. Say, let's assume I am publishing a message called say key1 Mohan1. Record rejected. Why? Hold on. Key1 Mohan1. Hey, what's happening? Because of the okay, let's do one thing. Instead of making the things complicated, let's publish to something called okay. As it is a, if we want to publish the message in key value pair, we must mention the properties, right? That's a producer that keep print.key and parse.key. Where are we passing that? We are not. Okay, I got it. So I'm looking for a property, hyphen property, parse.key is equal to true, and then hyphen property print dot key dot separator is equal to column. Fine. Now it will work. See, it will definitely work now. So now you are understanding the difference of a compacted topic and deleted topic. P1, message 1. See, now it has taken. Oh, come on. Key is not null. Key is there. Okay, let's do one thing. Instead of publishing the message to TP1, let's publish to something called TP10. So TP10 topic is already there in mohanwanda.training.com Kafka cluster. Let's say it will publish. Okay. Hi. Hello. How are you? What are you doing? So now see, the client from mohan2.trading.com in their Python program they have to use this command and they have to execute their Python program, so that what this command will do is it will connect your Kafka cluster which is running on mohan1.trading.com at 9092 and it will publish the message to Kafka topic. So we are in Mohan2, which is client mission, and we are able to successfully produce the message to Mohan1. So this is what the client server. Now let's try to consume. Simple. Kafka console consumer hyphen bootstrap server mohan2 dot mohan1 dot training.com 9092 hyphen topic tp10 hyphen from beginning. Okay, we will get all the messages. See, we have got all the messages. Now these messages have been transported from client mission to server mission, and over the network through this DNS, messages have been traveled. So this is what the client server in real time. This is what that is going to happen. So that's what the client server. It's very simple. Instead of executing the producer and consumer commands in your Kafka server, you will execute from a Kafka client mission. That's it. Nothing else. So if you see, I have in a Linux server and my server name is mohan1.training.com, right? Now here I have already started Kafka. If I do ps-ef pipegrep Kafka, so I can see my ZooKeeper is running with the process ID 2314 as a Ratna user, and also my Kafka is also running with a process ID 2376 as a user ID with the, as a user account Ratna. Correct. Now, if I want to see the topics list, what I can do, I do Kafka topics hyphen bootstrap server, and right now my Kafka is running on a mission called mohan1.timing.com. This is the host name 9092 and hyphen list. When I see the list like this, then I can see the topics. Correct. Now, okay, let's wait. Now see, so these are the topics that have been created in this Kafka broker running at 9092. Correct. But the thing is, every time being a Kafka administrator or any Kafka developer, every time executing this command, creating the topics from the CLI, it's like you need some in-depth knowledge, right? You need to know where is the Kafka path installed and how to execute the path. What are the options you need to invoke? What is the thing? Some technical knowledge you must have in terms of Kafka administrative perspective. Then only you can do this. Correct. But the thing is, for the for administrators, okay, this is fine. They must be having some knowledge, they can execute. But in terms of developer, they are not Kafka admins and they don't know about all these commands, all these in-depth options. So what they do is they will take the help of some Kafka GUI tools. With the help of GUI tools, we can remotely connect it to the Kafka clusters. So we can see all the topics and you can perform all kind of administrative perspective as a GUI mode. For example, Like in Kafka, we have so many GUI tools. Like we have the main things. Number one is Offset Explorer, and then the Conductor. These two are the main two tools. And we have something called Yahoo Kafka Manager. We have Zoo Navigator. All these are also Kafka tools. Okay, but let's talk about the industry standards, which are about Offset Explorer and then Conductor. So first of all, I will show you Offset Explorer. Then I will show you the Conductor. So for Offset Explorer, first of all, it's a open source. It's a completely open source. So you can download it freely from the internet and you can use it in your real-time project. Now, to install Offset Explorer, first of all, we must have download the Offset Explorer software, right? So for that, so in the google.com, what I will do is, I will do this thing, Offset Explorer download. Hit enter. So you will get something called some website called Kafka tool. Like in initial days, around 6 months back, this tool is called as a Kafka tool, but now the name has been changed to Offset Explorer. So there is something called download Kafka tool Offset Explorer. So click this so that you will redirect to a website called Kafka tool website, which will be having Offset Explorer product, Offset Explorer tool. So this is an ultimate UI tool for Kafka. Now it is having, the latest version of Offset Explorer is 2.1, and you can download it for Windows 32-bit, Windows 64-bit, Mac operating system, and then Linux operating system. So right now I want to use it in my desktop. From my desktop, I have to remotely connect to any of the Kafka cluster. So the thing is, I will download Windows 64-bit Offset Explorer 2.1 version. So if I click download, so that this particular software will be getting downloaded. See, it is now getting downloaded, right? And this will take around 2 minutes of time, but right now I don't want to download because I have already downloaded, I have already installed it. So let me cancel this. So the thing is, it is downloaded in my F drive, and then Offset Explorer, where is it? Yeah, see, Offset Explorer 64.exe. I have already downloaded it and already installed it also. So if you want to install it, right, you just do double click, and then that executable file will be open. So click run so that it will start installing. Hope in the Windows you know how to install a software, right? The same procedure. So it will ask some confirmation like this. So click on S button so that it will start installing. See, welcome to Offset Explorer. Now it says that a previous installation has been detected. Do you wish to update? I mean, already installation is there in my operating system in my computer, so that it is saying that boss already installation is detected. So you want to update that. I might be having some lower version of Offset Explorer. That is the reason it is asking me to update. Let's do one thing. Let's update. I will select S update. I will click next. I accept the agreement. Next, and then see it is preparing installation. Now Offset Explorer is getting the latest version of Offset Explorer is getting installed in my computer. So that will take a few minutes. Let's wait. So completing Offset Explorer, simple. So installation is very simple. Now once it is done, to open this Offset Explorer, what you have to do is in your computer just type something called, I will do something called Offset Explorer. See, it is there. I mean, here in this location. So just click this so that this tool will be opened. Offset Explorer, it looked like this. Already some cluster is there. Let me remove this. I don't need this. Now here the thing is we can add n number of Kafka cluster. For example, we already have one Kafka single node cluster running in my Linux server, and the host name of my Linux server is mohan1.training.com, right? So the thing is, in the clusters, just do a right click, and then there is something called add new connection. Click that, and it will ask the properties. So first, in the properties tab, the first option is going to be cluster name. So you can give any name here. For example, I am giving Mohan test single node cluster. I am giving something like this. You can give any name, it doesn't matter. Now Kafka cluster version, always select the latest version. So here the latest version I have is 2.7. So let's select that. And then the ZooKeeper host. So right now my Kafka and ZooKeeper running on which machine? On this mohan1.training.com, right? So just paste that. Just type that mohan1.training.com, and in this machine ZooKeeper running on 21814. So once you enter that, there is a ping button. Try to click this ping button so that it will verify if at 2181 really a ZooKeeper is running or not in this machine. So this is my Linux operating system, my Linux server. We are in Windows server. So click ping. See, server is listening on the specific port, which means in this server, ZooKeeper is successfully running at 2181. So click OK. Now there is something called security. Click on security. Right now we have not enabled any security for our Kafka cluster. It is like plain text only. Plain text means not security. You remember, like in the server properties, we have something called listeners and advertiser listeners. So in the listeners and advertiser listeners, we have given plain text, which means it's not a secured. So just select as a plain text. Now in the advanced, here you need to provide your bootstrap server, which means your broker host name and then colon broker port number. So it would be like this. Right now my broker is also running on the same machine, which is mohan1.training.com colon 9092. This is how we need to mention. And then there is something called a test button below. So click the test button so that it will try to connect this machine. So from the Windows machine, now see, connection successful. You want to add this connection? Yes, I want to add this. See, now Mohan test single node cluster has been successfully added. And the host where it is running is mohan1.training.com, which is our Linux server, and 2181 is ZooKeeper port. Now there is a red symbol. Red symbol means connection is added, but it's not connected. So do right click, and then there is something called connect button. Click the connect button so that, see, the red button has been turned to green button, which means we have successfully connected our Kafka cluster, and this is the configuration we can see here. So properties, security, advanced, JAS, ACL, so many things will be there. Now there is a plus symbol here. If you click this, you can see brokers directory, topics directory, consumers directory. So just to select the broker directory. Okay, there is only one broker running with the broker ID 1 with the on this host at 9092 port. This is my Kafka configuration. And if we select here, there is only one broker. So we have right now only single node, right? That is the reason it is showing only single node. In the multi-node Kafka cluster, if you see, you can see all the brokers. If we have 10 brokers in one Kafka cluster, all the 10 brokers will be displayed here. And there is something called topics folder, right? Click the plus symbol here. You can see all the topics that are created. So right now, if I want to create any new topic, right? The thing is, see, in this machine, previously when we try to list out the topic, you have to execute this lengthy command so that you will see the list. But with the help of Kafka tool, just click this. That's it. These are the topics. Right now, if I want to create any new topic, I will just click on this topics list, this topic folder. There is something called a plus symbol. I will click this plus symbol. Now it will ask me, hey, what is the topic name you want to create? The topic name I want to create, let's assume Mohan test topic. Partition count I will give only one. Replica count, as this is a single node Kafka broker, single node Kafka cluster. So replica count now qualified is only one. So click add button. That's it. Topic has been created successfully. See, I can see Mohan test topic. And you can see that from this list also. For example, if I see the list, if I execute this list command from the server, you can see that topic. See, Mohan test topic that has been created, right? So this GUI tool, it's very simple and very awesome tool, very helpful tool, especially in the real time. Just click and play. That's it. And for right now, okay, if I select TP1, again there are options: properties, data, partitions, and then config, which will describe the configurations of a topic. So to see the configurations of a topic, we have to set so many parameters. So we have to execute a lengthy command, right? Using Kafka configs command, by using --- add config command. I mean some lengthy command, but here just these are the configs. So its cleanup policy is compact, deleted retention MS 100, minimum cleanability ratio, retention MS, segment data MS, everything we can see. So if I see the data, for example, if there are any messages that will be displayed here. Right now in TP1, there is something called messages hold list, right? If you click this, yeah. So if you play this button, whatever the messages that are there in this particular TP1, everything will be displayed. Right now in this TP message, see, there are total two partitions for TP1, partition 0 and partition 1. In partition 0 at offset 5, there is a message called 8,000 rupees. And in partition 1 at offset 7, there is a message called 35,000 rupees. In partition 0 at offset 6, there is a message called 5,000. So something like this you can see. Understand?
Yeah.
So it's like very simple. Now the thing is, if you want to, through command prompt, if you want to see a message, you have to go to the Kafka file system. You have to do a cat, and I already told you that's not a recommended way. So this is the recommended way to see the topic contains which message. Now let's do one thing. I will put another new message. I will publish. Okay, some producer want to publish a new message in TP1. So command look like this. So we just select this partitions. Let's assume there are 3 partitions, right? So let's assume I want to publish in partition 2. So select the partition 2, go to data. There is something called plus. Plus means, see, whenever I just hover over my mouse on plus symbol, I got something called add message. Hey, I want to add a message. Just plus add a single message. Now what I will do is enter manually. I'm typing a message. Hi, how are you? I'm just typing a message. Click add. The records file is the validation broker and what? Invalid record exception. What is this? What is this? The record has failed the validation on broker. Hold on. I think this is compacted topic. Okay, compacted topic. This is not the way. You need to put a header first. Key value pair, right? Icon Explorer. Yeah, see, message headed to offset 4. The reason was this TP1 was a compacted topic, so I think there is some specific format we need to use. But for TP10, we have message has been successfully added to offset 4. Okay. Now, if I select this thing, if I click on play button, see, this is the message. Hi from Offset Explorer. One message we have put, and that one we can see. And let me put another message, something called add a single message, enter manually. Some message, do you know me? Now let's add message has been successfully added to offset number 5. So do you want to add another message? No, I don't want to add any other message. Now if I again click on play button, see, now I can see 2 messages. Offset 4 is having this message and offset 5 is having this message. right? So the thing is, if you want to search for any message, there is a filter option here. You have to filter, just type me, like whatever the word that contains me, that will be automatically filtered here and that will be displayed here. If I remove me, you will see everything. If I just type hi, you can see all the messages which contain the word called hi. So this is the way you can search for a message. This is the right way from the tool you need to search. Understand?
Mm.
All right. So this Object Explorer is really an industry standard, and this is an excellent thing. So most of the developers in the real time they use, even the admins also. For example, in my current project also, if I got any request to create any topic or to change any conversation, I never go to this command prompt. I never log into the server. Nothing. I simply open Object Explorer. I select the cluster, right click, add topic or add config or create config. Simple, done. This is how in the real time. If any problem comes for the troubleshooting purpose, then only I will go to the server. Till then, for normal kind of support activities, for creation, deletion, altering, for normal kind of things, I also use Offset Explorer only because it's very good time saver here. If you go to the server, you have to kill some time, which is again again a time killer. That's it. So clear with the Offset Explorer. We are going to start a new module that is called Kafka Security. So Kafka Security, we are going to discuss about SSL security, which includes, three parts. First part is encryption, second part authentication, third part authorization. So today we'll finish these three modules. Only encryption will take much time, but authentication authorizations are very simple things. Before start this Kafka security, we'll review one small session. So in real time, how does a client connect to Kafka server? Simple. We will be having two servers where in one server our Kafka will be running as a single node Kafka cluster. And another client server is a application server where applications are running, and from this application server we will connect to our Kafka. So if this server will be having our Kafka binaries and our Kafka process is also up and running. But in the client machine, only application is running and only Kafka binaries will be installed for producer and consumer stuff. And that's it. Kafka won't be running in the client machine, right? And from the client, we will be able to connect to our Kafka server for putting and getting the messages. For example, if I go to mobile scam, right now I have in one machine. Okay, so let me do one thing. Right now, this is our which host name? mohan1.training.com, where here Kafka binaries are there and our Kafka process is also running, which means this is a Kafka cluster, correct? This is a Kafka server, mohan1.training.com. And there is one more server which is mohan3.training.com. So in this machine, so Kafka binaries are there. If I go to this Kafka part, I just install the binaries. If I do ls, all my Kafka binaries are there. But if I do ps-ef pipe get Kafka, do you see any Kafka processes running in this machine?
No.
If I do host name Mohan3, so in Mohan3 there is no Kafka processor running, but Kafka binaries are there, which means this is a complete Kafka client machine. But mohan1.training.com is a complete Kafka cluster, right? Now let's assume from this Kafka client, so we are connecting to our any producer, say Kafka console. Some producer is trying to publish the message to our Kafka server. So Kafka console producer -- bootstrap server. It is connecting to mohan1.training.com mission :9092. See, we are physically in Kafka client mission, which is mohan3.training.com. But we are connecting to mohan1.training.com at 9092 port, which is our Kafka server, our Kafka cluster. And if I select something called, let's assume the topic is Mohan test topic. So this is what we have created, right? Yeah, Mohan test topic. So let's try to publish some message here. Hit enter. So now the thing is, we are connecting here Kafka console producer connecting to this cluster. See, The client, okay, disconnected. Might be some network issues, but if I press one enter, fine, it's now connected. Now if I put something called message 1, see, message 1 has been successfully published from Mohan 3 to Mohan 1. It means this message 1 has been successfully transported over the network from Mohan 3 to Mohan 1, and this has been successfully published into this topic which is running in this server. Now if I type message 2, so message 2 also successfully published, message 3 has been also successfully published. So in between Mohan 3 and Mohan 1, these messages have been transported over the network, right?
Yeah.
But also, if I try to consume the messages, let's assume /Kafka console, right? Still we are in our client machine. Kafka console consumer -- bootstrap server, say mohan1.training.com, which is our Kafka server, Kafka cluster, 9092 -- topic mohan test topic -- from beginning, so that we will be consuming the messages from Mohan 1 cluster, from the topic Mohan 1 test topic. So see, we are in Mohan 3, we successfully connect to this cluster, and whatever the messages that are there that have been successfully reverted back to our client machine, which means all these messages which are in this topic from this server have been transported over the network, and that communication happened between Mohan 1 to Mohan 3. Correct? That is what happened in the backend over the network. Now the thing is, in Kafka cluster 9092, it is a plain text port, it is a non-secured port. Correct? Now for example, if I go to my Kafka machine, if I open my server.properties file, so this is my server.properties file. Here if I see broker.id, and there is something called listeners, you see that? Right now these listeners, okay, let me do one thing. Already I have enabled SSL. Let me delete that. Give me one moment. Alright, let me save the thing. Let me restart Kafka once. Kafka server start ps-af Kafka. Okay, it's not down. Yeah, it's down. Now only ZooKeeper is running. Now again I'm starting my Kafka /Kafka server start -daemon home Ratna confluent etc Kafka server.properties. Now if I do ps-ef Kafka, right now see Kafka is also running. Now if I open the server.properties of Kafka, here you see the listener is now it's a plain text at 9092, and the advertise the listener, it means for the client also it is connecting to mohan1.training.com as a plain text. Plain text means it's a non-secured port, it's a completely plain text. Whatever the communication that happens between your client and Kafka server, it's a plain text. So the thing is, now let me show you one diagram here. Okay, the thing is, we have something called Kafka client machine, which is mohan3.training.com, and we have Kafka server machine, which is mohan1.training.com, where our ZooKeeper and Kafka running as a single node Kafka cluster. So the thing is, let's assume right now there is no SSL enabled, only plain text is enabled at 9092 port. So whatever the messages that will be transported from Kafka client to Kafka server, that will be transported over a plain text pipeline, which means any invader, any hacker can easily tamper your data, they can damage your data because there is no security, it's a plain text, right? But in the real-time industry, in the enterprise organizations, security, it makes a lot. It is very, very necessary for them, because if you are working for a financial organization, if you are working a banking organization, and you are dealing with the sensitive data, or if you are dealing with the financial related data, definitely security is going to be high priority in your organization, right? Now the thing is, to protect your data while it is over the network, when it is transporting over the network, when it is in the air, when the data is in flight, you have to encrypt your data, you have to protect your data. So you have to make a secure communication between your client machine and your Kafka server machine, so that no hacker, no invader can tamper your data. Your data won't be hijacked. Because let's assume this is the situation. You are handling some sensitive client data, and some hijacker, let's assume security is not there, and hijacker is hijacked your data. Now your client's data is not managing by you. It is managing by the hijacker. Just imagine the situation. Can you deal that? Client can go to anywhere, right?
Yeah.
Right. So protecting data is, very crucial these days. So to protecting the data, Kafka is having 3 layers of security. Number one, SSL encryption, that will to encrypt the data. That is to build a secure pipeline between your Kafka client and your Kafka server. That is encryption. Second thing is SSL authentication. So here we are going to use SSL total SSL security. So the first layer is SSL encryption, that will encrypt the data, that will encrypt your network pipeline communication between client and server, I mean Kafka client and Kafka server. Once encryption is done, then you can go with this. You can go to implement by the second level of security, which is SSL authentication. Let's assume here we have one server, one client machine. Right now, let's assume, okay, we have successfully built SSL encryption. Now, after building SSL encryption, whatever the data that you are transporting over the network between your client and Kafka server, that is now encrypted, that is now secure. But the problem is here, some problem is Kafka does not have some ability, some inbuilt ability it is not having. And the ability is, it won't identify, it won't authenticate the client. Whatever the connection that comes from the client, right, that will be authenticated as an anonymous client, which means anyone can connect to a Kafka server once you prove your encryption, which is again a problem. So Kafka server, you have to allow authenticated users only. You should not allow anonymous connection. That is again dangerous. Or of course you are encrypting the data, because without implementing SSL encryption, definitely you can't go for SSL authentication. That's for 100% sure. But after encrypting the data, once your client, your let's assume your hijacker also identified how to encrypt your data, right? So he can connect. That is the reason SSL authentication will come into picture. So now this client has to prove his authentication. Now to enable this SSL authentication from Kafka server.properties file, we have to enable a property called SSL client path equal to required, so that Kafka will be having an ability. Okay, now I should not allow anonymous connections. I have to allow the clients which are proving their authentication in a SSL mechanism. That is what SSL authentication. SSL authentication means Kafka will be having ability to authenticate the client. By default, Kafka does not have. By default, Kafka won't have any authentication mechanism. It will allow all the connections as an anonymous connection. But after implementing encryption, we will implement SSL authentication by giving this property, SSL client path equal to required property, in our Kafka server, so that our Kafka server will be having to identify the client. Whenever this is enabled, anonymous users, anonymous clients, they cannot connect. They must prove their authenticity by providing their own SSL certificates. So in the SSL authentication, I will show you how to enable this property and what are the steps that client should follow to prove their authenticity. So that we'll discuss in the authentication. Now let's come to the authorization, which is the final level of security concept in the SSL. So in SSL authorization, what we are going to do is we are going to give some ability to our Kafka server So this particular client, for example, in step number 2, we are enabling SSL authentication. As you see on the yellow color, this is a SSL authentication. Now client is proving its authentication. Now, whenever client is proved its authentication, Kafka identify, okay, this person is connecting to me. For example, my Kafka client proves its authentication as Ratna. So client is saying, hey, my name is Ratnakar and I'm connecting to you. Please allow me. This is my certificate. So client is saying like that. Now Kafka identifies, okay, you are connecting as Ratna. Fine. You are not an anonymous connection. You are saying that you are Ratna and I can see your certificate is fine. Okay, you can enter my Kafka cluster. Now the thing is, after entering into my Kafka cluster, to which topic you need to connect and to what kind of exact operation you need to do. That kind of list will be maintained in the authorization. Like although client is proving its authentication, he should not connect to all the topics. He should not disturb other application people's topics. He should connect to his own specific topic and he has to do some specific operation on his topic only. He should not disturb the other topics. That is what the authorization is. By putting some ACLs, like Ratna user can connect to TP1 topic and he can just publish the message, or he can just describe the message, or he can just do some kind of operation, whatever you want to do. That's it. So that is what SSL authorization. So in the security, like we have 3 levels of SSL security. Number 1, encryption. I already told you what it means. Authentication, we have discussed about it. And then authorization, also we have discussed about it. So let's start with the encryption. So for example, now I have 2 servers. One is Kafka client machine and one is Kafka server machine. Right now, this mohan1.training.com is my Kafka server, where it is a single node Kafka cluster running as a plain text at 9092 port. This is what scenario we have. And right now, as a plain text, the communication is happening between your Kafka client and Kafka server. We can publish and consume the messages. Correct? Now, to enable SSL encryption, so first of all, what we need to have is, we need to have something called CA, Certificate Authority. What this certificate authority is, this certificate authority is a third-party vendor or it could be an internal vendor. He will manage your certificate. He is the person to sign your certificates based on some specific algorithm. Like right now in the market, we have so many CA companies where the famous companies are Verizon, Thate, which is South African based CA. So all these are very good CA companies, right? So it's a certificate authority which will help to sign your certificates. So this signing will be having their own logic, which is very, very hard to decrypt. So I mean, invaders, the outsiders, they can't decrypt in such an easy way. So how to create this CA, that I will show you. But real time, we don't create any CA. We will be having the CA itself. But here we don't have any third-party CA or we don't have any internal CA. Here we are going to create our own CA. How to create a CA, that I will tell you. Now come to Kafka server, which is our right-hand side. So in Kafka server side, the first thing we need to do is we need to create a key store. So key store, in the sense, key store is a place where your keys are stored. Key means your SSL key, your SSL certificate detail. That is called a key. So the place to store that key is called a key store. So we need to create a key store. So how to create a key store, that I will show you. Once key store is created with a proper key, now we need to request our CA, boss, please sign my CA. So we need to request our CA, boss, please sign my certificate, which is mohan1.training.com. Okay, here there is some typo mistake. Hold on, let me correct. We will request our CA to sign our mohan1.training.com. For this, we will generate a CSR, which is certificate signing request, and we will share that CSR to our CA. Now CA, what he will do is, he will sign your CSR and he will send you the signed certificate. That the signed certificate we are going to store in our key store. Now our key store in mohan1.training.com, this is now signed by this is a server certificate signed by our CA. Now our key store is having a signed certificate. It's a proper signed certificate and we are paying the money to CA to sign the certificate. Now key store is ready. After key store is ready, we have to create something called trust store. So trust store is nothing but a key store only, which is also having a certificate. But the difference is going to be, the trust store will be having CA certificate. So this CA will be having a public certificate, The thing is, whenever CA is signing a certificate, they will send you the signed certificate and they will also send you the public certificate of their own CA. That public certificate we have to put in the trust store so that your server, your Kafka server will trust, yes, this is a trusted CA, this is a trusted CA authority. That is what the trust store is. So CA cert means CA public certificate, CA root certificate. If I say CA root, if I say CA cert, or if I say CA public certificate, all three refers to the same thing. Don't get confused. Okay. So how to create this trust store, how to place CA public certificate in this trust store, that I will explain you. Now, once key store is ready and trust store is ready, then we need to invoke them to point to our Kafka server.properties. We need to update. So how to update, that I will show you. How does they work in real time means very simple. Key store will be having your server certificate, your Kafka server certificate, and that is signed by this particular CA. Okay. Now, this particular CA that has to be trusted by your server. Then only server identify whatever the certificate that is signed by the CA, right? Please blindly trust it. That is what the trust store. If trust store is not there, then this Kafka server does not trust anyone. It has to trust one CA, right? Trusting CA means if any connection is coming from this CA, you can allow that because it's a trusted CA. So if the connection is coming from a different CA, don't trust it. That is what the meaning of trust store is. So with this, we have completed the configuration in the right side part, which is our Kafka server. Now let's come to the client side. So in the encryption, now we have did something in the server side. We built our key store servers. We have created a CSR, then we have get it signed by our CA. Now our key store will be having signed CA. Now we created trust store and we are trusting our CA. We have given the configuration in our server.properties file of our Kafka server. Done. Now let's come to the client side. Now client side has to do, they have to do something. Now our Kafka server is not at all a plain text Kafka. It's a SSL enabled Kafka. Now whoever will do some handshake with this Kafka server, they can only connect. So now the clients, they have to do some small thing. First thing, they should have something called a trust store. So like for Kafka server, we have created a trust store, right? Same like for the Kafka client also, we need to create a trust store. And this trust store will be having our CA public certificate. Now your Kafka client will be having the public key of CA and your Kafka server is also having the same public key from the same CA. Now these two will be trusted each other. They can talk to each other. That is the reason we need to have trust store on both the ends. Now this is trust store should be invoked as in Kafka client. So how to invoke that I will show you. Now with this we have completed certificate setup. Once certificate setup is completed, let's assume Kafka client initiated to connect to either to produce a message or to consume the message from mohan1.training.com. Now, whenever a client is trying to connect to Kafka server in the back end, first of all, what our Kafka server will do is, now our Kafka is not a plain text, right? It's a SSL enabled Kafka broker. Now, what our Kafka server will do is, it will send its signed SSL certificate to the client in the back end over the network. Now, our Kafka server is having a certificate, right, which is signed by our CA. That signed certificate will be sent to the Kafka client, which it is trying to connect to this Kafka server. Now, whenever Kafka sends this SSL certificate, now what Kafka client will do is, Kafka client understand is, okay, now this mohan1.training.com, this Kafka server is now SSL enabled Kafka, which means I need to verify its certificate. Now, the SSL certificate that is shared by this Kafka server to this Kafka client, that will be verified by this Kafka client. And this Kafka client is already having some trusted entry of your CA root certificate. And the signed certificate which is shared by Kafka broker to Kafka client, this is also signed by the same certificate, right? Now the validation will be definitely success because CA is same across all. Whenever this is done, something called SSL handshake will be happen. I mean, once the verification is success, some handshake will be happen between Kafka client and Kafka server over the network. It says that, hey, I can trust you, man. You can please connect to me and you can consume the messages or you can publish the message to me. Once this communication, this handshake is happening, now a secure pipeline will be established. A secure SSL encrypted pipeline will be established between Kafka client and Kafka server. Now message will be transported via this secure pipeline in a encrypted way. And all this encryption algorithm will be managed by your CA. For that only we are paying the money to your CA. Now no one can enter this pipeline, no one can crack this pipeline because it's now highly protected, highly strengthened by your CA. This is what the encryption is. Whenever we are implementing the SSL steps, technically we are following, please remember this diagram in the mind so that you will have a clarity what we are exactly doing. Otherwise, we will be getting confused. Okay. The first thing we are going to do is we will create a key store for our Kafka server and we'll get it signed. Then we'll store the signed certificate into our key store. Then we'll create a trust store and we'll invoke this trust store and key store in our Kafka server properties. Then we'll come to our Kafka client side. Then we'll create a cluster for our Kafka client. And once done, we'll invoke how what is the SSL property file this Kafka client should have. And after that, once this client is initiated a connection, how that will be validated, how that will be encrypted, how message will be transported, everything we are going to see. Now, just to flash the diagram, just to remember the diagram and follow the steps here. So in Kafka broker side, the first step is we need to have a CA authority. If you see the diagram, CA authority. So this is what we are going to see now. So creating CA authority, first of all, what I will do is I will go to my Kafka server, which is my, okay. So here I will go to client here. Okay, I will come out. So in home Ratna directory, first of all, what I will do is I will create a separate directory called SSL. File exists. Okay. mkdir SSL. Oh, sorry. Okay, let me remove them. Already things are there. I might have SSL CA. Okay, now what I will do is in home Ratna directory, I will create a directory called SSL directory. Now SSL directory is there. I will go here. Now I will create all my certificates, all my CA here only. Okay. Now first of all, in this part, right now there is nothing. In home Ratna SSL, right now there is nothing. Now what I will do is I am creating a CA part. For creating a CA, the command look like this. So we should use something called OpenSSL command. This OpenSSL command that you no need to configure anything, that will by default come with Java itself. So once you have Java, that is fine. So OpenSSL will work. Now OpenSSL, then we are requesting for a new key with a 4096-bit RSA algorithm. This is the algorithm format we are creating for CA. And this is having some validity of 365 days. And -6509 is going to be the format of your CA. And then the subject means your CA name. Here I am creating some CA with the Kafka Security CA. This is the name of my CA company. If you see in the case of Verizon, it would be something like Verizon. But here I'm just typing something called Kafka Security CA. And the key out. Key out means CA's private key. Out means CA set. CA set is a CA public key, which is CA root certificate. And hyphen nodes, which means I am generating my key, my CA in this node. If I hit enter, see, it is generating RSA private key. Now see something called private key, CA key has been generated. If I do ls-lrt, now you will be seeing two files, CA key and then CA set. And these are the CA keys which we have generated here. Now our CA is ready. So CA key is, it's a private key of our CA, which is highly confidential, and this should not be shared. This should be only with the CA. Now CA set, this CA certificate is a public certificate. You can share it to anyone whom you want trust. That's it. This is CA set is that fine, you can share it. But CA key, it's a highly dangerous, highly sensitive file. Don't share it with anyone. Now CA has been generated. CA has been generated. we need to create a key store, right? Okay, let me go. For creating a key store, command look like this. We need to use some command called key tool. Key tool is a command that will again come with the Java itself. You need to have Java installed in your machine so that key tool will work. If you don't have Java, key tool will never work. So we already have Java, so key tool command will definitely work. Key tool -gen key, which, okay, let me copy paste this. Let me copy paste and let me show you. So copy. Okay, command look like this. Key tool -gen key, which means we are generating a key for key store. Key store means we are generating a key store, and the name of my key store is Kafka1ks.jks. Okay, let's do one thing. Let me change this. Let me change this. Key tool, I am generating a key store with the name mohan1ks.jks. This is the name of my key store, which is having a validity of 365 days. And I am giving a password for my key store. And the password for my key store is mohan1ks@123, which means if I want to access this key store, I must use this password. If I forget this password, you can't access this key store. And then I am giving password to my key also. -key pass means in the key store we are generating a key, right? For that key also I am giving the same password. Whatever the password I have given for my key store, the same password I am giving for my key also, mohan1ks@123. Now I am generating a key with the name -d name. -d name means distinguished name. In the distinguished name, you will be having some 5 components. Number one, CN, which stands for common name, and then OU, which stands for organization unit, then O, organization, then L, location, then state, the state where your server is there, and country where your server data center is there. For example, here I have given first of all CN. CN means what is the name of your Kafka server. That server name you have to mention. This is point number one. Here our server name is mohan1.training.com only, so I am mentioning that. And organization unit, let's assume it is for infrastructure unit, so I am just giving IT infrastructure. And O means organization. Let's assume I am working for a company called IBM, and so I am giving something called IBM NA Holdings. For example, if I am working something called a Google company, here I may give O is equal to google.com, something I may give. Now the location. Location means now in the CN we have given our server name, right? Now this server is physically exist in which location? Here I have given something called Philadelphia. It means the data center where this server is exist. That the data center is in Philadelphia. Now state means my location. This Philadelphia is in Pennsylvania state. Now C is equal to country, which means this state is in US country. So this belongs to your entire server key. That will completely defines the name of your server, which company it belongs to, which unit the server belongs to, at which location the server is exist, what is the state of the location, and what is the country of the state. This is what the complete key is. Now the key store is created, right? Now if you want to physically see what is the content, what are the keys in my key store, there is a command called key tool -list -key store, and execute this command. So copy. Now this command just it will list out once you created a key store, right? Always recommended just open the key store and see what is the content there. If I hit enter, see it will asking me to enter the key store password. It is saying that boss, you are trying to see the content inside this key store. Fine, it's absolutely fine, but please enter what is the password of this key store. Please enter that, then only this will be opened. And while creating this command, we have given a key store password like this, right? mohan1ks@123. Just copy paste it. I just copy pasted, hit enter. See, now key store has been opened. Now this key store is having one key, one entry, and the name is my key. And you see the owner, this is the key name, and right now this is the issuer. It's a self-signed right now, so he is the issuer. right? And it is having some algorithm, some signature algorithm, some SHA-256. All these are the fingerprints. These are completely internal to certificate. You no need to worry about it. Right now, you need to verify, okay, who is the owner and who is the issuer. Now, once key store is created, now we have to request our CA to sign our certificate, mohan1.training.com. Now we have this key, right? mohan1.training.com. We have to request for the certificate. We have to request to sign the certificate. To request it, now see, to get the signed version, first of all, we have to generate a CSR file, like do a certificate request. We need to do something called certificate request. There is a command called key tool -key store, your key store name, certificate request. This option you need to use because you need to request for the CSR. You need to request for the signing, right? So command look like this. Copy, I go to the server, I execute this command. So now see, key tool -key store. Okay, this is the key store, and you are requesting a file called Kafka1.csr. CSR means certificate signing request. I am requesting for certificate signing request. If I hit enter, again it will ask for the key store password. See, whenever you access this key store, you must remember this password here. If you forgot this password, you can't do anything. So this is the password. So somewhere you need to safeguard this. So shift insert, enter. Okay, now something is executed. If I do ls-lrt, now see, you see a file called kafka1.csr, right? You see that?
Mm-hmm.
So from this key store, I have requested some file. Here the file name could be anything, but don't forget to mention the extension .csr. Now, if I open the content of this file using cat command, content will be opened of CSR. See, this CSR is having something called begin new certificate request and end new certificate request, which means it's a certificate signing request. This is not an actual certificate. This is just a request for signing your certificate. That's it. CSR has been generated for your key store. Now, CA has to sign your certificate. Now, see, to get the signed version, so we did a certificate request. Now our CA has to sign. So the thing is, in the real time, this CSR is there, right? ls-lrt. This CSR is there, right? You have to email to your CA team, boss, this is my certificate signing request. Please sign my certificate, so that they will sign it and they will send to you. Here we have our own CA. So there is a command to sign our certificate, and the command is OpenSL command. Again, here we are invoking CA, right? Okay, let me do like this. Let me remove this. Okay, so there is a command something like this. So copy and then paste. Now see, again we are using something called OpenSL command x5999, and I am requesting my CSR, which means I'm invoking two things. I'm invoking my CA public certificate. I'm invoking my CA key also. I am requesting my CA, boss, take this file as an input, which is a CSR, and give me output as a Kafka1.crt, which is my signed certificate. And that certificate should have 365 days validity. And that is the command. This is something called serial key will be generated. That you can ignore this option. But this is the command that CA team will execute in the real time. They do the same thing. They will execute this command and they will generate the CRT. CRT means it's a signed certificate and they will send to you. If I hit enter button, now see, you will get some output called signature OK. Whenever signature OK means for this particular subject, for this particular key, yes, we have generated a private key. And if I do ls-lrt, now you can see something called Kafka1.crt, which means now you have your CRT. Now in real time, what CA team will do is they will send you, they will email you this particular CRT file. Whenever you see something called CRT, yes, now I have received my signed certificate file. Now if I cat this Kafka1.crt, see, a personal signed certificate which will be having something called a begin certificate and end certificate, which means it's a signed personal certificate. Now we have Kafka1.crt, right? Once Kafka1.crt is there, which means your certificate has been successfully signed. Now we have to load our CRT certificate into our key store. Now we have completed till here. Now see, now in our key store, we need to add two things. Number one, CA certificate, CA public key, and then our signed certificate. Both certificates should be added in the key store, right? First of all, let's add our CA certificate. CA public certificate is there, right? Whenever CA are sharing your signed certificate, they will share you this CA certificate also. So now we need to import CA certificate and then our signed certificate. So first of all, let's import CA certificate. So this would be the command. Copy, paste. Now see, key tool -key store. We are accessing this key store, and I'm giving something alias, some name called CA root, and I'm importing a file called CA certificate. Now we have CA set in this path, right, which is CA public key, which we have generated in step number 1. That certificate I am adding in this key store with this name, CA root name. Enter. Now it will ask for my key store password. What is my key store password? Mohan1 case password is this one, Mohan1 case at 123. So copy and then paste, enter. See, now it is asking, hey, you want to trust this certificate? The thing is, this is CA certificate, which is CA public key, right? And our key store has to always trust that CA certificate. Then only the communication, the proper communication will be established. So always type S and then hit enter. Now see, certificate was added to the key store. Now your certificate has been added. If I do LSF and LRT, now Mohan1 case size has been increased. Previously it was like 2800 bytes. Now it is 4214 bytes. Now we have added CA root certificate. Now we need to add our main certificate. Our Kafka certificate is there, right? What is it? Yeah, this one. Our main Kafka certificate is there, right? We need to add that. So this is the command. So copy, paste, hit enter. Now key store password. Now in this key store, we are adding our main certificate. We are importing that file, which is our signed certificate by our CA. So the password is going to be Mohan1 case at 123. So copy, paste, enter. Okay. Now you got something called certificate reply was installed in our key store, which means now in your key store you have CA public key and also you have a signed certificate which is signed by the particular CA. You both have entire chain, certificate reply chain has been successfully installed in our key store. If I do LSF-LRT, now see, size has been again increased. Previously it was 4214. Now it is 5702, which means your key store now having two things, your CA certificate and then the signed certificate by that particular CA. Now, if you want to see the content of this particular certificate, simple key tool -list -key store mohan1 case.jks, enter the password, which is mohan1 case at 123. Now see, okay, let's use -v symbol also. So mohan1 ks at 123. Okay, now see, output would be bit length. Now this is the place where we have executed the command. Now boss, your key store is having two entries. First entry is your CA root entry, which is our Kafka Security CA. Now come down. If you come down, there is another private key entry, and this is your private key now. This is your common name you have given, and you see who is the issuer, who is signed it now. It is now signed by Kafka Security CA. Now it's a proper signed certificate with this algorithm. This is the certificate chain algorithm. This is the algorithm. Now with this, key store is completely ready. We have a server certificate signed by our CA. This is done. Now we need to create a trust store. In this trust store, we need to import our CA public certificate, and the command look like this: copy, then paste, enter. Oh, something wrong. Why? Import certificate of a chain. Hold on. Oh shit, I have deleted something else. 1 second. So copy, let's do the password also. So copy, paste. Now see, key tool, key store, Kafka 1TS. Kafka 1TS may, okay, it's a trust tool, right? Let's do one thing. Control H, Kafka 1TS, let's change it to Mohan 1TS for our simplicity. Copy, paste. Now I'm creating a trust store, that the blue color one in the diagram. Key tool key store. I am creating a key store with the name mohan1ts.jks. TS means trust store. Alias CA root, which means in this trust store, I am creating a certificate with the name CA root. And here I am importing a file called CA cert, which is my CA public certificate. And for my key store, I am giving a password called mohan1ts123. If I hit enter, this trust store will be created, and the certificate, your CA certificate will be added, and this should be added as a trust entry. You want to trust the certificate, obviously we need to trust our CA. So hit yes, type yes, and then hit enter. Done. ls-lrt. See, now I have something called mohan1ts.jks. Now trust store has been added, right? Now trust store is added, the final thing. Now we need to alter, we need to edit our server.properties file. We need to invoke that. We have to open our server.properties file. We have to invoke this property. Listener, advertiser listener, then key store location, key store password, key password, trust store location, and then trust password. So let me do copy paste of all these things. Copy, ls-lrt, pwd. Right now my certificates are home Ratna SSL, and this is the place. Okay. Now what I will do is vi home Ratna Confluent etc Kafka server.properties. If I go here, so the first thing, okay, remove this listener. Now listener is not like this. Now remove the advertiser listener also. Advertiser is also not like this. Now just copy paste. Now the listener. Now our listener is not a plain text listener anymore. It's like SSL. And our SSL port is going to be 9092. Or else let's do one thing here. For simplicity, I have not saved the file. Let's do one thing. Let's copy all these things. Copy. Let me open server.properties. Oh, I quit it with the save. Okay, that's fine. So listener is going to be SSL 9092, and in the advertiser listener, now there is no plain text. It's a SSL. So it will be something called SSL colon and mohan1.training.com, your host name, colon 9092. This is how it will look like. Now come to SSL key store. So where we have created a key store? We have created a key store in this location, right? Which is home Ratna SSL mohan1ks.jks. Make sure there are no typo mistake in the path. Now key store password. What is the password of my key store? It is mohan1ks@123. Then key password. Key password is also same we have given, which is mohan1ks@123. And then the trust store location. So the trust store also in the same location, but with a different file name, which is /home Ratna SSL mohan1ts.jks. Now the password is going to be, for trust store we have a different password, which is mohan1ts@123. This is what we have given. Now let's save the file. Let's save the file. Now let's verify once. If I do cat, it's always we need to verify pipe grep ignore case into SSL. Now see, listener is a SSL 9092, advertise listener SSL this thing, and then key store location. Let's verify this. ls-lrt. Okay, perfect. Key store is fine. Now trust store location. If I do ls-lrt, yes, trust store is also fine. Okay, perfect. Now restart your Kafka, because when we change the properties of our Kafka, right, we must restart our Kafka. So to restart our Kafka, it should be we have to go to compliant bin / Kafka server start. ls-lrt ps-ef Kafka. Now Kafka is down. Again, I am starting it. Kafka server start daemon home Ratna compliant etc Kafka server.properties. Hit enter so that Kafka will start. If I do ps-ef Kafka, see, now Kafka is running. Oh, Kafka is not running. Kafka is down. Kafka is not getting started. Why? Now I am also a bit clueless why Kafka is down. I will go to the log and I will see. I will go to cd .. logs. Now I am in the logs path. If I do ls-lrt, okay, vi server.log. If I come down, okay, see some error. Exited Kafka due to fatal error. Required argument. Oh, we are missing one argument. What is that? Interbroker listener name. All right, I got it. So the thing is, when we are having only SSL listener enabled, right, we have to give something, some parameter called interbroker listener name in our Kafka server properties file. So let me give that. It would be, we have to give something called SSL. This one we have missed. Interbroker listener means the broker has to communicate in which way? It should be in a SSL way. So we have to mention that. That we have just forgot. Okay. Now I will do this in my server.properties. So copy. Let me exit the file. Now cd etc Kafka server.properties. Enter. Okay, here itself I will give something called interbroker listening. So this one we have missed actually. I'm giving this. Hit enter. Now I'm starting my Kafka. So I will go to bin path / let me execute the command. Yeah, server start server.properties. Hit enter. Now if I do ps-ef Kafka, perfect. Now Kafka is running. Let me go to the logs. Let me show you something. vi server.log. Now see, now Kafka is running fine, no error. Now see, these are the properties that have been loaded. Number one, advertise the listener. It has taken SSL property, correct? And also, if I come to listener, okay, interbroker listener name that has taken SSL, which we have given, and then come to listener. Listener is also now SSL. Now our Kafka is a completely SSL. There is no plain text at 9092. Now, if we come down, there is something called SSL properties. See, SSL key store location. This is what we have given. SSL key store password. Always it is hidden. And then SSL trust store location. This is the location. And SSL trust store password. This will be always hidden. Now, all the location that has taken according to our requirement, what we have given in server.properties. And also, my Kafka is now running. Right? Now our Kafka is complete SSL thing. Now see, come on. Okay. Now our Kafka client Mohan3. See, right now server side we are good. We have done everything, but Kafka client we have not done anything. Right? We have not invoked any trust store. Right? Now let's see. Now without having a trust store, if a Kafka client wants to connect, what happens? We go to the server. Let me close this guy. Okay. Already Kafka is running. See, my Kafka server.properties is running with the 2384 process ID and as a Ratna user. Also, ZooKeeper is also running with 2316 process ID as a Ratna user. And this is my client machine where only Kafka binaries are there and the Kafka is not running because in Kafka client machine, Kafka won't run, only application will run. And if you see, the console produces that properties. So while producing the messages, he is invoking client.properties file where it is having encryption detail, where your trustworthy certificate is there, what is the password of trustworthy, and what is the SL protocol. All three will be there in this properties file. And he is connecting to 9092 SSL port. If I hit enter, so he will be connected successfully. So let's say hi. Hello. So now all this hi hello messages have been transported in a encrypted way through a secure pipeline. So these messages must have not been hacked because we are invoking a trusted entry through SSL port 9092 port. Also, when we execute Kafka console consumer by invoking my trusted entry, so these all the messages that will be coming from Kafka server to Kafka client as an encrypted way. So those came in a safer security line. See, all these messages have been came now from server to client, and these messages came in a secure way with a encrypted in an encrypted format. Now, so we have successfully did SSL encryption. So step number 1 is done. Let's come to the second level of security, which is SSL authentication. So SSL authentication is a way like it is a process of enabling authenticating the client. Right now, through in an encrypted way, the communication is happening between Kafka client and Kafka server. But right now, our Kafka server does not have the ability to identify, to authenticate client. Hey, who is connected to me? Here, the thing is, whoever connecting to me, just by providing this client.properties file, just this server trust stored entry, he will be connecting. But Kafka does not identify who is this exact user. Kafka does not have the ability to identify. So the thing is, to enable SSL authentication, to enable a capability of authenticating a client, we have to give a property ssl.client.auth equal to required in our Kafka server, so that Kafka will get a mechanism. Kafka will get the ability to identify your client. For example, right now what we are going to do is we'll go to mohan1.training.mission and will give this property and I will restart Kafka. Again, let's try to connect without authenticating and let's see what is the thing we are going to get. See, SSL client authentication after encryption. So let me open this. Now to enable authentication on the broker side, so we have to give this property and then we need to restart our Kafka broker to make this change effect. So let's do this. Right now our Kafka having the encryption capability, but it is not having the authentication capability of the client. So I will go to my Kafka broker, which is mohan1.training.com. I will open my Kafka server.properties file. Complaint Kafka server.properties file. Now here, so we already have the encryption details, right? Now here, what I will do is I will give another property. This is to enable client authentication. I will give a hash comment to this line, and then I will give something like this. SSL client auth is equal to required. Now I will save the file. I will restart my Kafka server stop. The Kafka is not stopped, not rebooted. No, yeah. Now see, my Kafka is now down because I can see only ZooKeeper properties. Okay. Now my Kafka is down because I can see only ZooKeeper properties is running. So server properties is not running. So Kafka is down. Now let's start Kafka. Kafka server start -d1 home Ratna compliant etc Kafka server properties. If I do ps-ef Kafka, now see Kafka is running. Now I will go to log file and I will show you one thing. I will show you that the particular effect, the particular change what we have done. See cd log vl server.log. So if I open this, it is taking into effect. SSL. Okay, so this is not the updated configuration then. If I scroll up, yeah. So here are the configurations. See here, yeah, you see now SSL client path is equal to required. Our given property, that property has been taken into effect, right? Now let me save the file. Okay, now your client is connected. So I am in the client mission now. Now your client is connected. Your client is trying to consume the messages by invoking trusted entry. Client.properties file is trying to consume the messages. Let's see if we will be able to consume or not. See, he is able to consume. Yes, see, some error came. What is the error? Failed authentication due to fail to process post handshake message, which means handshake is working fine. That's fine. But this client is failed to authenticate with this particular broker. So we are connecting to Mohan Wanda training.com and this is the IP address at SSL port 9092. But now this client is getting failed authentication. Boss, failed authentication is not happening. Also, you see SSL authentication exception, failed to process post handshake messages. This means after handshake, it is failing. After handshake, what's happening? Authentication is getting failed, which means authentication is getting failed. Now, the thing is, if I go to the diagram, now my Kafka broker is a SSL authenticated enabled broker, which means whoever clients connects to Kafka broker, they must prove their authentication. Previously, in just encryption, if they give the this encrypted the trusted entry, that's fine. Your connection will happen. Now, client has to also prove the authentication because now my Kafka broker is a SSL authenticated enabled broker. Client must prove their authentication. Now it's client responsibility to prove their authentication. Now what client has to do? What client has to do? What client has to do to prove their authentication? It's very simple. To prove the authentication in the client side, they have to generate their own certificate. They have to get it signed with their CA, and then they have to invoke them in the client.properties file. See, that in the client side, first thing, with the help of keytool command, the client will generate their own key store, and then they will get it signed by the CA, and then they will load this CA set and this signed certificate into this particular key store. Now this key store will be having authentication details of the client. Now when they invoke them, the key store location and key store password in the client.properties where client authentication is there. Now the handshake, the proper handshake will be happening between client and server, and then message will be published. Now let's see. Let me do one thing. Let me copy this for your information. I will wait. Okay. Let's assume in our case, okay, the user Ratna is connecting. So let me replace Mohan KS.jks to Ratna KS.jks. Replace all. Done. Now let's assume the CN name is Ratna. Right now you can remove this. No need to mention all these things. It's just a user, right? Just put something like that. Now store type this one. Fine. So I'll just update the thing. So now Kafka is enabled broker. So in the Kafka client side, so client has to generate its own key store and its own key, and this is the command. So yesterday we have created the key store and key for the server side, right? For the broker side, right? Now we are preparing it for the client authentication side. Let's assume my application is running with a user called Ratna. It means I want to prove my authentication as a Ratna user, right? So let me use this. Copy. Then I will go to my client machine now. So in the client machine, let's assume I will go to a particular path. So let's go to some temporary location. In temporary location, what I will do is I am executing some command called key tool, generating a key. I am generating a key store with ratna case.gks. Why I have chosen ratna case? Because I just assume that my application is running as a ratna user and which is having a validity of 365 days, and this is the password of my key store, and hyphen distinguishing name is cn is equal to ratna. So this is the certificate. This is the authentication I want to connect. So store type, algorithm, and then key size is equal to 2048. Hit enter. Now I am executing this in Kafka client machine. Now if I do ls-lrt, now I get this something called ratna ks.jks, right? Which means my key store has been created, and this is the password of my key store. Now the thing is, we have to get it signed. To get it signed, we have to get the CSR file. We have to get the certificate signing request file, right? So, and the command is this one. So copy, paste. So the thing is key tool hyphen key store. We are invoking this key store, and from this key store, we are requesting a CSR file, which is certificate signing request. Hit enter. Definitely to ask for the password of this key store. So this is the password of that. Hit enter. Okay. Now if I do ls-lrt, now see ratna.csr has been generated. So if I cat this ratna.csr file, begin new certificate request and a new certificate request. Now this is in a proper format of in a requesting file. Fine. Now we have to get it signed by our CA. So CA is common across all the organization, across the entire organization, right? So your CA is only one. Now the thing is, in our case, our CA is in Kafka broker side, right? If I go to if I go to SSL, see our CA is here, right? In Kafka broker side, this is the path where our CA is there, right? So whoever CA you have used to encrypt your broker, the same CA has to sign the certificate. CA is common, only one. If you use different CAs, then our certificates are not going to communicate to each other. So CA is only one. Now the thing is, with the help of our CA, we have to get our CSR to be signed. So what we'll do is we'll get this CSR file to this server first, and with the help of this CA, we will get it signed. Again, we'll SFTP that CRT certificate into our client server. Okay. So first of all, let me get the certificate CSR file into my Kafka broker machine. I go to SFTP, where TMP. This is my CSR. I will download to my desktop first. Okay, it's now downloaded. Now I will go to my Kafka broker side. What I will do is I will go here, home, Ratna, SSL. Here I will again upload it. Now I am uploading to my Kafka broker machine. Ratna.csr. Fine. If I do ls-lrt, now I have the CSR file here in Kafka broker one, and I have my CA certificate also here. Now let's do one thing. Let's try to get it signed by our CA. And how to get it signed by our CA? We already know OpenSSL command. So let's execute this. So copy, paste. So OpenSSL X509, we are requesting, hey CA, I am giving this file as an input, and please give me this file as an output, which is our signed certificate, and which should be having 365 days of validity. That's it. Hit enter. Done. Your signature now. Okay. After creating the key store, what I have done was okay. So this is the command to create a key store. and we need to get the signed certificate. For that, first of all, in the client side, I have generated a CSR file for my client key store, and I have imported the CSR into my broker side where my CA is there, and from there I have get it signed. Now, in my broker side, I have the CRT file. Now this is my signed certificate. Now this signed certificate we have to get it to our client side because we have to store it in our client key store, right? Now, actually, generally in real time, what you will do is you will send the CSR file to your CA. So CA will send it to you, and again CA will send you this CRT file. That's what in the real time. Yeah. Now I have Ratna.crt file. I will upload to my desktop. Oh, sorry. I will download in my desktop. Now, yeah, it is now downloaded. Now I will go here. Again, I will upload in this path in where PMP location. Upload Ratna.crt. It's now uploading. Done. Now I have .crt file in my client machine. Now this .crt file should be loaded in this key store. Okay. The thing is, before uploading this signed certificate into this key store, we need to upload CA public key also, because whoever signed the certificate, he should be there in the key store first of all. Otherwise, this CRT file can't be uploaded in the key store. So let's get the CA certificate also. From my Mohan1 tribing file, there is a CA key, right? This is CA key. I will download to my desktop. I will upload here. So CA key. Done. If I do LSH and LRT, now see, I have CA key and I have CA certificate. So first of all, let's discuss about what is ZooKeeper forum and why it is important and what is the role of a ZooKeeper forum in a multi-node cluster setup. Role of a ZooKeeper. So the thing is, we already know some basic idea about a ZooKeeper. So like ZooKeeper provides multiple features of distributed platforms, like it will manage the distribution configuration management, then self-election and concession building, then coordination, then key value store. So like this, ZooKeeper will do many things. And ZooKeeper is used in many distributed platforms like Hadoop, Kafka, etc. So ZooKeeper is not only limited to Kafka, but also in Hadoop cluster also, we will definitely use the ZooKeeper, because ZooKeeper is a distributed platform that can manage your cluster. So it is an Apache project. So this ZooKeeper has been introduced by the company called Apache. So what Apache did was Apache has launched this concept of ZooKeeper. But the thing is, this ZooKeeper has been proven very stable since long and has not had any major releases for several years. So the thing is, whatever the ZooKeeper setup we have right now, so that is enough to handle your entire clusters. Whether your cluster is having one server or your cluster is having many servers, millions of servers, the particular ZooKeeper can handle the load. Okay, now let's see the structure of a ZooKeeper. How does a ZooKeeper structure look like? So a ZooKeeper structure look like a tree. So for example, in our Linux file system, the file system structure is like a tree, which is having main file system, after that sub branch, after that branches, then sub branches, then files, folders, like this. As you see the diagram on the left hand side in the blue color, the slash is the root file system of a ZooKeeper. Under slash, we have a directory called slash app, and then under slash app we have something called slash app slash finance and slash app slash sales, which means app directory has been subdivided into two subdirectories, right? So here this is a node, this is a root node, this is one node, this is another node, this is another node. So each and every node is called as a Z node because these are the ZooKeeper file systems. So each Z node has a path. As you see on the diagram, this Z node is having a path, and its path is slash. Its path is slash app. This one's path is slash app slash finance, and this one's path is /up/sales. So Z node can be persistent or ephemeral, which means persistent means once data is entered, that's it. It won't damage. You can't change it. It won't go. Ephemeral means you can alter it. So each and every Z node, this could be a persistent Z node or it could be ephemeral Z node. Each Z node can store the data, and a Z node cannot be renamed. So once Z node has been created, you can't rename it. It is fixed. Each Z node can be watched for changes, which means if any changes are happening in our ZooKeeper architecture, so changes will be updated in the ZooKeeper node.